Good afternoon, everyone. I hope that you've had some lunch. And this afternoon, this session is going to feature talks about decentralized AI. And in my opinion, it's one of the most interesting areas right now in crypto. And to kick it off, we have David Menarche from OLAS. And in my opinion, one of the most important projects working at the intersection between crypto and AI. So please give it up for David.
Hey everyone, thanks for having me, and thanks for coming inside despite the nice weather outside. So we'll talk about how to bootstrap an autonomous AI agent economy. And no worry, there's a lot of words there, we'll uncover it. So first, I present you this very scientific study about economic growth. So I went ahead and asked ChatGPT about economic growth. And here above, we have the growth so far at around 100 trillion US dollars world economy. And with the arrival of autonomous AI agents, we're looking at up to quadrupling that in 25 years. So here we go. Obviously, that's a joke, but that is actually a real response from the model. The point why I'm showing this isn't to argue whether this is a correct prediction. Doesn't really matter. But what's important is for you to start thinking about what would it mean if autonomous AI agents arrive at the scene at large and basically contribute to our economies. What if all of us have one or more autonomous AI agents that do things on our behalf? Because what does autonomous AI agent mean? It's basically a software system which does things on behalf of its owner, which can be you, right? So let's look into this and find out. So who am I? I'm a co-founder and CEO of Valerie. That's a labs. We built open source technology. I'm also a co-founder of the OLAS protocol. And back in the day, did a PhD in economics on applied game theory. The mission we have at Valerie is to basically enable groups of people and individuals to co-own AI systems, and today we're focused on autonomous agents. For this presentation, I want to cover a couple of things. So I want to familiarize yourself with OLAS. Then I want to go into this topic of what do I mean by an AI agent economy. It'll be a very high-level description, and then I'll go into a use case example which outlines an AI agent economy which we can see today and where all of you can actually participate in. And then the important point, the actual title of the talk, I'll then equip you with the knowledge to basically go away and bring an autonomous AI agent economy to your protocol or your chain or more generally your use case which could involve some crypto or not. Finally, we'll cover some of the aspirations we at Valerie have for these kind of economies. And then we'll have time for questions. So everything I'm talking about here is not some sort of theoretical construct. It's based on actual iteration, actually working on this problem day in and day out. The OLAS ecosystem has generated more than 700,000 transactions across various blockchains. The primary one in terms of transaction counts is actually Gnosis chain. And we think we've therefore demonstrated that autonomous AI agents can be daily active users of protocols and chains and are actually growing that every day. The last time I gave this presentation in Denver, this 18% were 10%, now we're at 18%. So basically OLAS agents have now made a significant number of lifetime transactions of the SAFE protocol. The reason why SAFE, small aside, is because we use account abstraction for those who know what that is. But generally speaking, the message is AI agents aren't just coming, they're already here, and the question is now how fast are they going to grow. So OLAS, the protocol, and the stack are ultimately, in a nutshell, there to generate more autonomous agents and more autonomous agent economies, right? So what I mean by this exactly we'll cover in a second, but that's one way to think about OLAS. Now, on a technical level, what we enable is you as a developer or you as an operator, i.e. a person running an agent, to basically have these agents in different configurations. You can have an agent which runs on your local device or your cloud instance or your decentralized network, which does things on your behalf. We call that a sovereign agent. You can have the same kind of software deployed as a multi-node system. Think blockchain, but it's a different thing, where basically it forms a decentralized autonomous agent. If you want to go into the technical specificities of this, come to our stand, because it's quite involved. But ultimately, this allows a group, for instance, members of a DAO, to own one autonomous agent that actually, on a physical level, is a bunch of nodes collectively implementing this. And then where it becomes very exciting, and this is, in a way, no news, but we're leveraging it heavily in OLAS, is once you have multiple agents interacting, you have multi-agent systems. In multi-agent system, the key thing is that rather than what you care about coming from one specific agent, the thing which you care about comes from the interactions of agents. All of us in this room are actually members of multiple multi-agent systems, right? If you go to work, you're not there to do your specific thing. Your specific thing in isolation would be quite meaningless. It's the organization as a whole you're contributing to, which is a multi-agent system, and the emergent outcome is whatever your organization is shipping, actually. So really, what I'm talking about is just taking that concept which we have with humans and then moving it into the realm of software and thinking about how can we scale these systems and direct their attention exactly where we want them to. So final point on OLAS, I think, is that there's many different ways for you to get involved into OLAS right now. Depending on your skill level and what you're actually interested in, there's ways to contribute without any code if, for instance, you want to grow awareness about OLAS, or you can contribute in a more kind of DeFi way as a bonder. You can operate agents, you can build agents, you can launch entire use cases, and you can govern the protocol. Again, come talk to us. We can guide you in the right way, or you can just go to olas.network and to the Get Involved section. So let's get to the meat of it, and first describe at a very sort of abstract level what we mean by an autonomous AI agent economy. And I don't want you to take this as a canonical definition. It's just a definition. I'm probably going to have a new definition tomorrow. It's just one way to describe it. So there's different types of agents, autonomous agents. That's one requirement for a multi-agent system. And it tends to be the case that these agents specialize for pretty much the same reason we also specialize, right? There's this whole economic arguments behind why it makes sense for humans to specialize, and they equally apply to software agents. There's no difference there from an incentives point of view. And we tend to have many, many instances of these different types of agents. So let's say your specific use case has maybe 3 or 4 or 5 types of agents. Maybe your workplace has like 10 different types of agents. Then you still have like multiple software developers and multiple people working in product and so on. Each agent needs each other to get stuff done. So coming back again, workplace analogy, you are not going to achieve your outcomes there unless you work together. Otherwise, they shouldn't have employed you in the first place, or you shouldn't be there in the first place. And then in order to get stuff done, like humans, we need autonomous agents to communicate, which tends to happen off-chain, although occasionally can happen on-chain via smart contracts, and trade, which or contract and all the other cool things we can do on-chain, which tends to happen on-chain, but occasionally can also happen off-chain. So let's look at an example. OLAS Predict is a use case that involves a ton of people. Actually, some of them are just sitting here. Others are in the room and downstairs. It involves a ton of protocols. Basically, it involves 3 types of agents. So it's a multi-agent system with 3 types of autonomous agents: the market creator, the AMX, and the trading agents. And what they do as an emergent outcome is not anything any one of the specific agent does, it's what they do collectively. It is, they are meant to basically create prediction markets which end users that can, again, be autonomous agents or humans can consume. So far, this system has actually generated a ton of transactions, and so we can increasingly say a lot about the things that go well. We can improve the architectures, we can study the data, and we can actually use the data as well. So here's some highlights. So for instance, according to some benchmarks, they're not perfect benchmarks. These prediction tools have up to 75% accuracy. We've had over 89 participants in what's the staking test program called Coastal Staker Expedition. OLAS is launching this native staking program to the protocol. It's actually going into the Code for Arena contest next week. So if you're like an auditor, please participate and maybe win some bounties. But basically, yeah, this is the precursor. And what it does is it incentivizes operators to operate agents in this use case. But these operators, as we'll find out in a moment, and these agents are rewarded in a very specific way. It's not your vanilla, set and forget, and you'll just get some sort of emissions. And the other interesting thing is that there's been a lot of code contributions. So not just a lot of operators, there's also a lot of builders. So some of them, again, sitting here. And Napta, Polyrap, other individuals, Gnosis team have contributed code here. Now, I mentioned before, it generates a ton of data, and that's actually increasingly interesting, because if you think about any given use case that involves multiple agents, again, going back to the analogy of your business, you tend to get better by time through iteration, by updating your tools, your means of doing things. And what you ultimately want is that the data you're collecting directly improves your processes, right? You want this flywheel to be as uninterrupted as possible. And so the ideal flywheel is outlined here. So you have some sort of agent architecture you start with, which utilizes some sort of AI model or multiple of them. In the case of this use case, is the trader agent using these prediction tools. Prediction tools you can think of, for those who know what it is, sort of AI workflows. And then you have that working. Now you can give very measured rewards towards agents hitting KPIs. What do I mean by this? Well, in a very sort of traditional labor context, you often literally get paid for the exact labor you do, right? If it's measurable, you work 3 hours, you get paid for 3 hours. You slack for 2 hours, you ain't gonna get paid. That's exactly what happens here. So in OLAS staking, the staking model, the smart contract, defines KPIs, and then these agents have to work into these KPIs. When they hit them, they get basically rewarded. If they don't hit them, they have lost their the opportunity to earn these rewards. And if they slack for too long, they're going to be evicted from the system, right? And so you have a emissions model whereby agents are only rewarded when they're actually doing useful things. The nice thing is that these useful outcomes for end users then arise, right? So in this case, the prediction market, but we also get the side product, which is basically we generate a whole bunch of synthetic data from these agents interacting. So in this case, we get all these prompt prediction pairs and a whole bunch of other data that can be useful in going and training a better AI model, right? And that's exciting because one of the big problems with decentralized AI is training, and I'm not going to speak to this. The other is data, because if you ultimately want to have a good model, you need very good data. And how do you get that? Well, you need use cases that just generate a shit ton. And I'm not saying 100,000 data point or 1 million or even 1 billion. You need a lot of data. And so this means the more agents we can have which generate this as a byproduct, the better we can make our models. And so it's feasible then that we can take that data back to create some better models and then also some better architectures. So this flywheel is still sort of cranking, right? It's not spinning, but it's very exciting for us to basically iterate on that. It's where we spend a lot of time. Now, to the abstract. We had the specific use case, and so now the question is, how can you bring this OLAS protocol to a use case you care about and benefit from it. So the path this looks like is pretty straightforward. So you're, let's say, a protocol team. You define your goals. So you could imagine a situation where you're like some sort of DeFi protocol which cares about certain like actions to be taken or certain like liquidations to happen, things like that. You can define these as KPIs on that staking contract, and then develop yourself or with members from the OLAS DAO the agents which basically work against these KPIs. Then you deploy that staking contract, and you can then literally guide emissions to it by being a OLAS DAO member. So basically, members in OLAS DAO can guide these emissions. We'll see this in a moment. And then what should happen is that if you've built your agents correctly and if you've defined your staking contracts correctly, which is obviously not a small if, but that's the heavy lift here, then from that point onward, it's like a bit like a machine, right? You dial it up and you kind of increase the number of staking slots, you increase, like you configure the system, and it just grows. And like I'm not just saying this as some sort of theoretical thought exercise. That is literally what's happening with OLAS Predict. So we're in the third iteration of the staking contracts. The first one was Everest, then we had Alpine, now we have Coastal. They increasingly got simpler, and now it's a walk on the beach. And basically, at each iteration, we obviously got more data and were able to improve participation. From a token point of view, the way this looks like is that for those of you who know this model of Curve and the Gauge, it's a bit like this. So you have basically, for a long time in OLAS, governance is based around vote escrow. So basically, those who govern need to commit to the protocol for some time. So they need to lock the OLAS into VOLAS, and that gives them voting power. And for up to this point of OLAS staking coming live, this voting power can be used for things around developer rewards, for things around upgrading the protocol, and so on. But with this upgrade, what will happen is that basically members of the DAO can say, okay, well, this entity over here permissionlessly deployed the staking economy, and we care about that staking economy, or quite literally, the members who deployed that staking economy get some OLAS and care therefore about it, and direct emissions. So there's a competition for emissions, and the mechanism is actually quite involved. Come to the contest, the Code for Arena contest. Basically, we don't just blindly emit. I already mentioned this proof of active agent mechanism where you basically have agents being paid by their KPIs. On top of that, we also have all sorts of mechanisms which modulate that any given staking economy doesn't get too much emissions and all these kind of things. Now, what this means is that as soon as the system goes live, anyone who is interested in such a staking economy to arrive at their chain basically can do that permissionlessly. And this model in detail is outlined here with all the participants. Now, where do we want to go with this? So one big challenge with crypto AI or decentralized AI is that the crypto people are now very excited about AI, and the AI people don't actually care. But that's fine. It's not going to stay like this, because basically the value proposition is very, very clear. If I can own my entire autonomous AI agent, my AI models, if I can be sure that they are of the way I like them, whatever preference I have, that they are as transparent as they can be, that they are basically what I want, and no one can take it from me, that is a much, much stronger value proposition than one whereby I'm like on the behest of OpenAI or Claude or Anthropic in this case, or others, where at any day they can rug me in the sense that they can actually close my access, but they can even rug me in the subtle ways which they rug us every day, which is that the model constantly changes. If you ever run any benchmark against these models, it will go like this, right? It's not static, and that's an issue as well. So there's a lot of value propositions there, and we have to figure out how to tap into them and leverage them with our means. And then there's a lot of technical problems. But I'm not here to speak about the other technical problems. I want to provide you with a vision, and things I'm very excited about is basically creating more economies of agents. Because things we can then create is basically hospitals of agents. So in the beginning, this basically can be a means to research and complement existing kind of knowledge in the medical domain. You can imagine a Wall Street of agents, which in a way we have. DeFi already has quite a lot of autonomous AI agents, but I'm sure we can go further. You can imagine a Disney of agents, so someone who generates movies, and very high quality ones, where actually the capabilities are shared between these agents, and so you can prompt the videos you like without having to rely on some centralized provider to insert their advertising to show you all sorts of specific things, which is 100% what they will do, right? Centralized model providers. And then the Harvard of agents, you can have these researchers, as I mentioned, who complement your hospital of agents and so on. So ultimately, I think what we want is we want to create a lot of autonomous AI agents. I'm not so worried about the risks around this in the short term. We should worry about that in the long term. There was a great debate earlier. And we should very much think about how can we improve our health, how can we improve our wealth, and how can we improve our well-being by basically making it such that AI in the sense of models and AI in the sense of agents can be owned and accessed by all of us. So what I leave you with is basically a call to action to say, what autonomous AI agent economy will you create? And I really mean this, like go and sit down and write down a couple KPIs which you care about in the context of your protocol or chain, and then come to our stand, and then we'll have a conversation as to how you can make that happen. So that's what I leave you with, and then we have time for questions, and a thank you.
Thank you, David. Yeah, we have a few minutes for questions, just like 3 minutes. So, yeah, anyone have a question for David? Over here?
I think let's wait for the, otherwise no one.
Hi, thanks. Yeah, that was really interesting. I wanted to understand a bit better how you guys actually verify when a KPI has been fulfilled. There's like an Oracle problem there. Yeah, I don't think we went into that in the talk.
Yeah, great question. Basically, it's modular. So the architecture has certain it basically has a factory which is allowing you to create certain pre-existing modules, and then there's a way to add more. That's how it works on the smart contract level, and then conceptually, right now a lot of the metrics which we use are basically on-chain. So it's proxies often for the actual action someone might take, and for Ola's Predict that works just fine. I'm very excited, the Giza folks are around, other kind of ZK technologies are around, where you could imagine using elements of off-chain compute, verified off-chain compute, which you verify in that module to then unlock the staking reward. So it's totally open, basically.
Another question for David?
Over there.
Over here?
Hey, thank you for the presentation. My question is about, what is actually blockchain specific? I understand the presentation as you are basically just building agent systems which also happen to do transactions, right? Is there anything beyond that that makes these blockchain-based agents?
Yeah, great question. So there's a couple of things. So firstly, there's a protocol in the stack. The stack you can use in a way where it's basically just agents, like your Langchain agent or any other kind of agent. The one thing on the stack, which if you go for the sovereign agent type, is already on top of. It's this sort of, it's crypto native in the sense that you can more easily send transactions. There's all sorts of things which are already there. You don't have to code. Then we have this concept of the decentralized agent. So that's still arguing at the stack level, where basically you can code an agent as a single node. You can then run it as a distributed system. Under the hood, it actually functions like a blockchain. So the agents individually write to the synchronized state machine and then shared state machine. Then they basically can use the staking machinery underneath as well. So you have a pretty robust way of running off-chain decentralized systems that are autonomous. Because one of the key things with smart contracts, obviously, is like they're autonomous in a certain sense, in the sense that no one can turn off the blockchain, but they're not autonomous in the sense that they actually can do anything out of their own accord. So in that sense, they're actually not autonomous at all, which these systems are. So this is the argument at the stack, and then we have the protocol as well. On the protocol, if you come from economics, there's a term of mechanism design. So you can basically design a mechanism for a game to be played on top of it. And if you design the mechanism well and the game is well described, you actually know what will happen. You know the equilibrium ahead of time. That's a bit what we're doing with the staking. Like we're basically defining like KPIs, and if they're well defined and if the agents on top are well defined, then you kind of coordinate them to do certain things. And that's basically one of crypto's big things, right? It's all about coordinating actors. So in a way, like OLAS is just this omni-chain protocol which coordinates all these autonomous AI agents and therefore very crypto native. So those are the two parts.
If we don't have any more, one more question here, I think that's, we'll conclude it after there.
Thanks for the talk. I want to ask about the capability of these agents to have also a knowledge base, or better say like a knowledge graph, so they can have better reasoning based on that, and if there is any privacy features that can also be with that data.
Yeah, so the stack in general doesn't have any opinion as to that topic. Like you could use an on-chain knowledge graph, you could use something like an on-chain knowledge base, you can use some database, you can use like something in memory, you can use a vector. So like it really depends on your use case. ULAS doesn't have any opinion about it. Having said that, like obviously there's certain like use cases currently implemented which have a certain shape. I think one thing people often like, specifically the developers who want to understand it all, kind of look at OLAS and then you see a certain thing and you're like, well, this is the kind of agent I can build, and that is actually not true. So there's the stack and the protocol does not care what stack you use. We've built the OLAS stack to make it easy for people to get started. If you have a better stack, come and run a staking economy on top of it, and you'll be happy.
I think we'll wrap it up there. David, thank you so much for your talk about
Thanks.
agent economies. And next up, we have a talk by Joel Thorstensen, and his talk is entitled, Why Our AI Future Needs Data Provenance.
All right, thank you. And thank you, DappCon, for inviting me. So I'm by no means an AI expert, but I've had a lot of experience with data provenance because I've been building decentralized data protocols. And so today, I'll basically be talking about sort of my observations over the years and sort of how I think these two things intersect. So I wanted to start talking about sort of the problem of AI, like the risks ahead. And it seems like we're in this path, and there's basically two paths that both are kind of bad. So in one scenario, we go into a world there's centralized controls, someone controls all the AIs, there's no privacy, there's censorship, and I can sort of do what they want. And the risky thing here, I guess, like it also is like a winner-takes-all scenario, but this is not really like a future we want. And the other side, which I think the side that like many of us here probably are thinking is the right side, is like the decentralized AI, like everything, all the capabilities of AIs at the edges. And this is sort of nice if we think about it from like a self-sovereign perspective, but it actually brings a lot of risks. So deepfakes is one thing, but even beyond that, like if you can just use an AI to create sort of drugs or like very dangerous weapons, it's a real problem. And so we need to actually have some way of having alignment, which is not only aligning the AIs to humans, but actually aligning humans all across the world to like not everyone compete for this winner-takes-all centralized control scenario. So I wanted to start talking about trust. So if you think about this deepfake problem, there's a few different approaches that are being approached. The main one is being by a consortium of companies called Content Authenticity Initiative. And this is basically like a few companies coming together to sort of verify content online. And basically what it is signatures, hashing, and timestamping. And funnily enough, is stuff that like the crypto community is actually really good at. But what this looks like in practice is that you snap a photo with your camera. So maybe you have a Canon camera. That camera has a key on it that signs the content. And that key has a certificate from Canon, the company. Then you edit this photo in Photoshop, and Photoshop sort of signs that edit. And so you can have this like flow of all the edits that happen to a photo. And this is nice, right? We can, if the website supports it, we can actually look at all the things that happen in the edits, and we can know like, oh, this is definitely not a deepfake. There's sort of like two problems with this. The first one is that someone might not just use this and just upload a random picture without any metadata, and we have no way of knowing if it's like real or if it's a fake one. The other problem is that now we have these like big companies that all control what is like true, right? And we can imagine some entity maybe wanting to put pressure on all these companies to like censor some particular happening in the world. So like all the photos coming from that particular place actually is like now considered false. So there's like two problems with that. The other approach to this problem is something called perceptual hashing, which is basically taking a neural net, an AI tool, and looking at an image, generating sort of a hash that represents the picture. And you can have two different pictures that are like slightly edited, and you can get the same hash. So this is nice, and I think there's more to be explored here. But it sort of has problems that sort of neural net things have in general, which is that they can be easy to fake. And so there are some like problems like actually making this really robust. But even beyond these two approaches that I talked about, they really only apply to like images, audio, video, maybe like written content. But it doesn't really work when it comes to like the stuff we get with jailbreaking model and like generating like really harmful content. So imagine someone is using a model to generate like a recipe for how to make some drug or to how to make some kind of harmful weapon. That we really don't have a problem, or we don't really have a solution for this problem, except like the centralized control where someone sort of surveils everything and looks at what everyone is doing. And like the one key thing to realize here is that like if there's someone sort of that is not sort of mentally well, they might actually get access to a model like this and do something like this. And so we actually need, in order to solve this problem in a way which is not like authoritarian and surveillance state, we need some sort of web of trust. We need to have communities and peer accountability in like actually small groups of people. And that needs to sort of scale up to multiple layers up until like the entire planet. And so this is a really big challenge, and I think the Web3 community actually has the tools to be able to get at solving this problem. I think also if we have like a web of trust like this, it can serve as like a basis for something like quadratic voting and funding, which is a really good way of like thinking about more digital democracy. But how can we make this web of trust? Web of trust has been this like term that's been around for a very long time, and it never really like worked, never really took off. I'm sure a lot of people here, since it's sort of a Web3 conference, you've used Signal, but how many of us actually like go and verify all of our contacts that like actually verify each other's keys? It's just like a social interaction that is like has a lot of friction. So in order to make web of trust work, I think we need to make web of trust implicit in everything we do, all the actions that we do online and in sort of digital environments. So ideally, we can end up in a place where we can go to like an ether scan of data, and we can just look up any action that was taken and see that like, yeah, it's valid, and it was taken by this person that's like one hop. Basically, my friend knows them. But there's a problem with this, of course. It's like, if it's a downvote, should that be like treated the same way in terms of trust as a very good positive review? Well, obviously not, right? So how do we deal with that? We basically need some way for the computers to understand what's going on. And so there's actually been a long-standing effort to do this called the semantic web. For those who know it, it's kind of funny. The semantic web was the thing that was called Web3 before Web3 existed. So this effort by W3C to create a standard called JSON-LD to make the web machine readable. But JSON-LD never really took off. It's like burdensome for developers to implement it. But the nice thing now is that we have LLMs, and LLMs sort of solve this problem of making the web interpretable by machines. And we can create something called vector embeddings. And vector embeddings is basically pointing your model at a piece of content, like a website or a PDF or something like that, generating something called a vector that basically represents this content in a way that the AI model understands. And then we can create an index of this. So if I search the web, I can get results based on content. And if we can do this in a way where like all the content that individuals creates have embeddings, we can actually search sort of more in a more like human way with content. So I can say like, is this person over here, reputable when it comes to biochemistry? And I can get back a sort of written human language result, but I also have references to cryptographically signed sort of attestations from my friends, and like this hops to like make me trust that statement. And so this is pretty cool. Can we just like embed everything on the internet and have combining this with like the signatures we talked about before? We kind of can, but the main problem is just like, how do we trust the vector embeddings? If I have a piece of content, how do I know that this embedding this vector actually is accurate? Someone could create like a fake vector for a piece of content to put it in the wrong place. Basically, the way we would solve this would be to have these embeddings signed by people who actually run the model. So people who are running these like big closed models like OpenAI, Google, and so on, actually can you sign the outputs that they give us and assign the embeddings that we generate using these models. So that sort of solves the problem. Unfortunately, like it puts a lot of trust in these like big AI companies. Ideally, we could do something like making a zero knowledge proof of an embedding that is using one of these like open models like Mistral or the smaller Llama model. I think in theory this is possible. It's probably like really hard in practice right now. Okay, so great. We have all the internet as embeddings. Everyone has signed everything. This sounds pretty terrible for privacy, right? Like, we're not really that much better than the world where there's a centralized entity that's just like monitoring everything. So what do we do about that? Well, I think, first of all, we should just realize that in general, it seems like right now, AI is pretty bad for privacy. Everything we do basically involves talking to some company that gets all of our data, and in order to run these like inferences and give us like these really useful interactions that we get from AI. So in the Web3 space, there's been a bunch of talk about something called a data backpack, which is basically this idea that you put on a backpack, you put all your data in it, and you go around to different services and essentially like give those services pieces of your data and selectively disclose them. This seems like reasonable, but unfortunately, in the world of like an AI where we want as much relevance as possible, we're likely going to end up walking around with an open backpack where like all the services that we use just get access to all of our data. So it's not really like a great solution. And so I think what we really need to do instead is, instead of users taking their data to the applications that they use, we need applications to come to the users and use the data locally with the user. So we need to return to a world where we download the application and we run it locally on device. Otherwise, there's no way we will have privacy in the future. But we can do this, and we can also have social spaces between users where we have privacy globally, but we have like sort of sharing data and sharing our vector embeddings between people. And I think one of the cool things about LLMs is that we can actually use these tools to generate the applications that we need for the moment. So if I need a very specific way to like edit an image or edit a spreadsheet, I can just ask the AI model to generate that tool, and now I have it locally. Maybe no one else have it, but I can share it with them if they need it, and we can collaborate on that piece of data. All right, so I wanted to talk about a little bit of sort of few promising projects that are moving towards this direction. So first of all, Gitcoin Passport. They're basically building the fundamental building block of the Web of Trust. They allow you to basically verify your identity against like a bunch of different services, and then use that as a basis for a Sybil resistance score. And you can use this in Gitcoin, of course, to do quadratic funding, but I think it can be used for so much more, especially if they start doing more sort of privacy-preserving parts of your passport that you can use to selectively disclose to different people. Index Network is another project that is taking it upon themselves to sort of start building this global vector index of data on the internet, and started sort of doing that indexing. But I think what's really cool about Index Network is they have this feature that allows you to not subscribe to a channel, not follow people, but you can subscribe to a semantic search. So basically what that means is like I can go to like the application and say, hey, I want to know about all new hat tricks that happen in football anywhere globally. And I'll get sort of a data feed of like all of that happens when those sort of games happen, right? So that's pretty cool. Coordination Network and DeSci Labs are building sort of tools for decentralized science. So I think science can be like a really cool first use case for this type of Web of Trust, where in some cases, DeSci Labs, for example, is doing a decentralized peer review system. And so that's like really tangible of this like Web of Trust thing. Powerhouse is doing something similar, but mostly for DAOs. And so and Coordination Network is cool because it actually starts to allow you to customize prompts for different things and share those between users. So we can have this like on-the-fly generation of applications that are sort of moving in that direction. And so why am I talking about these projects in particular? Well, the thing they have in common is that they're all built on the project that I'm working on, which is Ceramic. So the main thing that Ceramic provides that makes all this sort of easy is that is mutable objects. And so these objects are version controlled. They're tamper resistant, so timestamped on chain, and they're signed cryptographically by end users, so with cryptographic access control. And the nice thing is these objects are independently verifiable. So I don't need to synchronize the state of the entire network to know the state of one object. I can download one object, keep it locally on my computer, and verify that independently without necessarily even revealing it to other people. And this is all in a global namespace. So all data on Ceramic is addressed with a cryptographic identifier, and each node can sort of select which part of the network that they share data to. Okay, so what about privacy? Well, right now, all data on Ceramic is written in public, and other nodes can synchronize it. One of our key focuses right now is building a physical access control layer, which means that I can select who is allowed to synchronize data from my node, and the data doesn't actually physically move around the network unless I allow it to do so. And with this, we want to push data out towards the edges so that users can hold their data without sending it around, and any type of like company or other entity can just like hold the data and share it with whom they would please. All right, so based on sort of what we talked about so far. Like what is really missing in the space of like data provenance and sort of the intersection with AI? I think we need better tools for community formation. And what this means is like this web of trust only really works if we can have some way of like determining what are the different communities and how do they interact. This is also like really important for things like quadratic funding and voting and so on. And so we need just like better tooling for creating communities. I think one thing that's really cool that comes out of the complex systems science realm is something called community detection algorithms. So this is actually like a branch of like research. So basically algorithms that you run over social networks to determine like what are the different communities in these social networks and sort of what are their relationship. More tools that use like quadratic voting and signaling. I think in particular it would be interesting to see sort of using quadratic curation to curate like an RLHF dataset that we can use to sort of have a more democratically trained AI. Finally, we need better ways of sort of having accountability between peers and in communities. And this needs to be at all scales, like small groups of people and friends, larger communities, nation state size, and like ultimately globally. And one key takeaway that has like is really impactful to think about, at least for me, is that in this world of like AI that's just like more and more advanced, the health of local communities is actually a critical requirement for us to have security globally. And so what I mean by that, well, basically, if there is like a community that has like a bunch of unhealthy, like mentally unhealthy people, they get access to the massively powerful AI tools and can use like, oh, I just want to destroy the world. And they just like go and figure out how to create some sort of bioweapon or something like this. That actually is like global risk. And so it's actually critical that our local communities are healthy so that we can have security globally. And I hope that with these tools that we've been building for years in the Web3 space, we can actually help to address these issues. All right, thank you.
Thank you, Joel. We have time for just one question. Over here.
Yeah, I'm sorry, it's not really a question. But I just wanted to congratulate on your last sentence. I think you're absolutely right. The only thing that a rogue AI could not attack is actually small communities, because that's where we can filter for AI. All other stuff we cannot filter for AI, and that's where we cannot defend. So yeah, that's probably the key to AI safety.
Yeah, it's really scary, but it's also like sort of, I want to live in the world where we solve that problem, because that seems really nice.
Thank you so much, Joel, for your talk. Round of applause for Joel. And we're going to keep it moving here. Next up, we have a talk by Vincent Weiser titled Abundant Compute and Intelligence Through Scaling Decentralized AI.
Hello, everyone. Thanks for having me. So I'm Vincent, the founder of Prime Intellect. And for the context, our focus is really to decentralize AI, also by really figuring out how to do decentralized compute, but also novel ways to advance AI models themselves. And for a bit of backstory, like spent the last few years kind of helping build up some of the first communities in decentralized science. So learned a lot about how to coordinate concretely scientific funding on Ethereum over the last 3 years. Started a project called VitaDAO that some of you might know, and spent also the years before that already in kind of like tinkering in AI, but also in crypto. So it has always been two of the spaces that I've been closely involved with, and so naturally evolved and asked myself also like really how can we decentralize AI in meaningful ways beyond kind of like hype. And that's what this talk is going to be about. So really about how to get to relevant amounts of compute and relevant models for solving and funding and advancing AI models through decentralized AI. Yeah, so the broader vision, kind of like with and motivation for starting this was really to kind of emerge from talking to a lot of AI developers, founders, academics at AI conferences over the last few years, and just friends starting AI startups, is really empowering them with more instant and scalable compute, but also really with novel incentives to make open source AI models work. And maybe to focus on the first one, really, like, if you talk to AI researchers and startups, like, the only thing they all have in common is that they don't have compute, basically. Like, and I've been chatting with them like over the last even like few days with a bunch of researchers doing some of the most meaningful models, and the only thing they really want and don't have is compute, because otherwise you can't do anything. But then also like they kind of lack the incentive models and frameworks to get funding for open source AI models. Like basically they rely on donations to an extent. And the broader goal with like solving this is really to kind of like advance scientific progress and really make access to compute universally accessible, as well as to intelligence. And I think like it will become increasingly clear also throughout the presentation, but like that it really should be almost like a basic right to have access to compute and intelligence, especially in a world where like all of your intelligence, sorry to break it, but will be basically worthless to an extent probably compared to artificial intelligence. So people will rely probably on having access. So talk is kind of like in three parts on like going into compute and intelligence, and then also how a protocol fits into that, and like how it could look like in a decentralized world. And maybe like to start off, I'm not sure how many of you are aware of like the scaling hypothesis, or have heard the bitter lesson of the scaling hypothesis. Okay, not many, so that's useful because like it's basically like the biggest lesson in 70 years of AI research is that generally methods that leverage computation are ultimately the most effective and by a large margin. And this quote from Rich Sutton, like one of the key former scientists at DeepMind, invented reinforcement learning. Yeah, and it's obviously clearly shown also on this chart to the right, is kind of like since we entered this like deep learning era, the main thing that changed is actually not the algorithms. Like GPT-3 or 4 is quite similar to GPT-2. The difference is just like orders of magnitude more compute, and literally like GPT-2 I think was like 20, 30K of compute, GPT-4 was more like 200 million. So it's like a huge jump in compute, and obviously also some algorithmic improvements. And so the first realization we had was like, to an extent, it's obviously highly centralizing force, because you have these gigantic data centers, like OpenAI has like 1 or 2 data centers with literally 10, 20 billion worth of compute in them. And the only way to an extent to compete is like if you can bundle and aggregate all the other compute in the world, in every other data center in every country, literally at some point, maybe even in every laptop and smartphone, into like one kind of like aggregated network. But it's very challenging to train across distributed compute, even if it's in 2, 3 different locations, and especially if it's like hundreds or thousands of different locations. So that's one of the core problems we started to tackle, is really how to train decentralized, how to orchestrate this compute in a like global fashion. And we started basically with this first goal and like launched our compute platform in private beta, like which basically aggregates compute from all the different GPU clouds, but then also enabling people to contribute their own GPUs basically onto the platform. And it already like enables people to basically find the cheapest chip that we can find in the world, like to train AI models. And I think the key thing to focus on, I think also from a lesson from observing crypto, is to like not only focus on the decentralized clouds, which some of you might know, like Akash or like Jensen or a bunch of others that are doing decentralized clouds, Render Network, and a bunch of others, but also the centralized ones, which still are 99% of the cloud. So it's kind of like just focusing on the decentralized clouds would be like a drop in the ocean of like the compute that is out there. And a lot of people also don't really care if it's like centralized or decentralized. So we kind of like go with both. Yeah, the focus really is on the one side to really aggregate all the compute we can like in the world and make it usable, like for people to use for training, fine-tuning, for inference, and other things. And yeah, this is kind of like, I'm not sure if the video works, but like it's a bit like how the platform works. Like it's just people basically looking for the chip they're looking for and finding like the compute that basically is like the cheapest, but also most performant for their need. And I think where this gets interesting, and which is one of our key technical research focuses, is on decentralized training. And for context, basically, most of the big models have been trained in a centralized fashion, like GPT-4 or others. But an interesting shift was actually recently by Gemini, by Google. Like they started to train distributed, like across multiple clusters, because not all GPUs could fit in one cluster. So they basically were forced by like the natural limitations of space and energy to train distributed on 2 or 3 clusters. And this will only increase. Like it's basically now kind of like known already from the comments, also from the AI people, that like we won't stop at 200 million. Like the next training ones will be 1 billion, and there will be 10 billion and 20 billion. Probably like stops out at like 10, 20 billion. But like that's like huge order of magnitude jump from where we are currently. So it's only possible in a decentralized fashion, and in fact, DeepMind is already doing it in a decentralized fashion. And we are basically right now focused on actually building on top of all the research and decentralized training, actually replicating what DeepMind is doing for the open source community and making it freely available. So they haven't published a GitHub, they haven't, but they've done a paper on this. So we are basically right now, like open sourcing this and building this out. But then also adding a few properties. Like the key is really to make this fault tolerant. So if one of the GPUs doesn't work, that it can just replace it with another different GPU. But also to an extent enable heterogeneous, like different basically GPUs. So you don't are limited to just using, for example, NVIDIA H100s, but also could use older generations or different kinds of chips. And then I think the key requirement which we are focused on is really this low network bandwidth, because you can imagine if you take a GPU in different places, say in the US and Europe, like you'll have to send data between them. And that's one of the key limitations, and there's ways around that basically by synchronizing less regularly, less frequently, and figuring out ways to approximate this in a way where it doesn't become a huge issue. And that's basically what DeepMind published on and demonstrated, and what we are now replicating and publishing is figuring out ways to like solve the inherent difficulties with decentralized training. And the key benefit is, of course, really, in going back to the first point, is like, if dollar is kind of the input, you want to get obviously the most amount of compute, and the cheapest compute is usually the underutilized compute somewhere in the world. So the whole idea is basically to always enable people to basically plug together the cheapest compute they can find in the world and train across the cheapest, basically GPUs people are willing to provide. So that's basically what, like we've built on this open source framework, also called HiveMind, additionally to what we're replicating from DeepMind, which is like an older, already decentralized deep learning framework written in PyTorch. And we basically enable people, like straight from our platform already, to basically contribute their compute to this decentralized training run to train the first like AI models in a decentralized fashion, basically where like hundreds of people can join with their compute to train it. It's more like a proof of concept to show that it's possible at similar, actually, like efficiency. And that's basically like one of the first things we're building right now, is really like building in MVPs and in quick iterations, like different paths to this vision of like, hey, let's train on like every GPU that is underutilized in the world. And then maybe like going into like how, for what to use all of this GPUs and this compute, we basically of the belief that obviously we'll have these gigantic models trained for like 10 billion, 20 billion by OpenAI, open source by folks like Mark Zuckerberg with Llama. But we'll also have like a range of like specialized models, obviously some of these fine-tuned models, and also kind of like for the related to the space I spent a bunch of time in with decentralized science. There's also a bunch of like domain-specific scientific models that are really interesting, obviously also like high impact, and that actually don't need 10 billion of compute, maybe like $100,000 of compute is enough for most of the researchers we're talking to. And like, for example, just yesterday I talked to a researcher working on like pandemic prevention, and like they need like $25,000 to build their model, and this model could literally prevent the next pandemic. Like, and so there's a bunch of this almost like low-hanging fruit to figure out like basically also coordination and funding models for impactful AI model builders to get their hands on compute. And obviously the key challenge there is really that we've seen this closed and fully open model where like obviously the big guys train in a closed fashion and then try to sell the AI model as a product like OpenAI or Anthropic or Google even. And then obviously the fully open source models like Llama just try to like cross-subsidize with Facebook, for example. And I think what we'll increasingly also able to see is some models in between. Like the best example is Stable Diffusion, for example, which obviously is freely available, like the code everyone can use. But if you want to use it as an enterprise, for example, you have to pay them. And I think that's like one model that will become more interesting and more commonplace is that people can still, like everyone can access the code, everyone can use it for free. But if you make a lot of money with it, you have to basically give some revenue back to the people that trained this model. And that's what we're basically exploring as a funding model. To give like millions of compute and then hopefully much more to like a bunch of people building impactful AI models in exchange for some sort of royalties. And there's this like good quote by actually a former employee from OpenAI who's now with one of the biggest like humanoid robot companies. And he himself said like the only way he could see for potential disruptor to the OpenAIs and Googles is if we could figure out ways to, on the one side, incrementally fork open source models and train all of these models further and merge them together with all the distilled compute basically that people are investing in open source AI that people have obviously globally kind of like available. So that's one of the key motivations to also explore novel ways for people to advance AI models in a decentralized fashion. And what you could imagine, for example, what we're looking into is like if, say, Facebook has announced that they'll release one of the biggest AI models, like 400 billion parameter model with Llama soon, which is probably on par with like the best closed models. But there's basically ways to continue training those models much more cheaply than they spend on to really enable a model that always stays ahead of the closed and open models by just like more and more people contributing compute, but also data and novel insights to this model. And how does a protocol fit into all of this? Like the core idea for us is like to actually like not start like crypto first, but like what's actually does the AI world need and like what do the AI developers need, and then figure out like does a protocol even make sense here? And basically how we view this really is like this. Like ultimately compute is a commodity, and a commodity needs like a market, needs like market mechanisms to be traded like efficiently. So like I'm of the firm opinion that like majority of GDP will be spent on compute, like won't be spent on humans, won't be spent on other things. Like it will be humanoid robots, will be like factories, but it will also be like a lot of compute because it ultimately scales infinitely, right? Like if you imagine you have like a few like tens of millions of scientists worldwide, you could have like 10 times or 100 or like 1 billion times more compute and intelligence spent on science just by ramping up basically scientific AI, for example. So like the whole idea is that like compute might become the biggest market in the world, and it's still not very efficient. Like it lacks kind of like a NASDAQ, it lacks a way to just use all of that compute. So that's at the heart of it, and really it enables more efficient price discovery on basically every sort of compute. So basically, obviously what we've seen with a bunch of the decentralized AI compute protocols is kind of like peer-to-peer compute, even in an abstract way. For me, Bitcoin and Ethereum are an example of this. Like it's like actually 100 orders of magnitude like more compute was contributed to Bitcoin or Ethereum than, for example, to GPT-4. So it's basically existence proof that like there are ways for people to contribute enormous quantities of GPUs and compute power to decentralized protocols. So that's one of the ways that I think one can bootstrap these networks, is just basically enabling people to compute directly, but then also really making more efficient use of this compute, and thus like driving up the value for the people providing the GPUs, but also lowering the cost. Yeah, so that's basically at the heart of it. And then really this decentralized training also enables like effective utilization, because you in essence could always use the cheapest compute in the world to train, which obviously is not possible if you need 10,000 GPUs in one location. But like if you could use a few GPUs here, a few GPUs there, and plug them all together, then you could always train, fine-tune, inference on the cheapest GPUs in the world. So that should, in essence, make the market more efficient. Like it should basically create demand for the cheapest providers of compute power in the world. And then really connected to that, like the interesting aspect is also figuring out this model for almost like community-owned, community-funded AI models, and I think there's different paths to that, and ultimately a bunch of protocols have obviously tried this out. Like one famous example is BitTensor, which obviously is just incentivizing basically AI models to become better and better. And I think there's some really interesting things there, but like also like some signs that it's not working perfectly or very efficiently. So they spent like $1 billion or $2 billion actually in incentives per year, and like they haven't produced like state-of-the-art models thus far. And so they have been produced for much less resources in other places. So which basically leads us to the conclusion there needs to be like a more efficient or better model to incentivize basically AI models with compute that actually make relevant progress. Yeah, so that's ties also into this high-level idea, also like again from Rich Sutton, which I mentioned earlier on the scaling hypothesis, and actually from David Silver, who's like probably the most relevant scientist at DeepMind, like he was behind AlphaGo, behind most of the key inventions at DeepMind. And they did this paper, Reward is All You Need. And I think it really also shows nicely why crypto will matter in the AI world, and like how also decentralized AI might shape up, which is really this idea of like crypto economics and this concept of almost like viewing crypto as like kind of like an environment where you design on the one side reward functions, but because it's also inherently financial, there's obviously a lot of incentives for bots to get involved. There's a lot of basically efficiency driven already by kind of like AI in crypto. Like I would argue, like from looking at transactions, like the majority is already done by bots, and I think that will only increase. Like wouldn't be surprised if it's the majority at some point. And I think that's also how decentralized AI will shape up, as to an extent a lot of these like agents and bots like will look for compute, and they'll look for compute in a trustless, permissionless way, and they'll want the cheapest compute, and they'll also like want to make money, right? Like on prediction markets, on DeFi, on other areas. So I think there's basically a future where one could see like a almost parallel and growing like ecosystem of AI like happening on crypto rails, and not only kind of like making money on crypto rails and creating value and services, but also using compute inherent and through crypto rails. And really this hypothesis of this article is that like intelligence and its abilities can be seen and understood as subserving the maximization of reward, so that almost like intelligence emerges out of like a reward function. And obviously like evolution is kind of like the reward function for humans, and obviously for AIs it's usually actually compute or financial rewards that it's trying to maximize, because it's kind of like its oxygen. Like if it doesn't have compute, it can't run. So the one thing it needs or wants is compute, and to an extent, yeah, like resources to run, which obviously is kind of like fungible. Like, yeah, so that's about it. Like, happy to, like, if there's time for like questions, take some questions, and happy to collaborate. You can find more out about us on primeintellect.ai. Or on X, and yeah, feel free to ping me, and happy to collaborate and explore ways, yeah, to work together. Thanks.
Thank you, Vincent, for your informative talk. A great example of why boutique and smaller projects can have such a big impact right now in AI. Any questions for Vincent? Do you have a question? Okay. Okay. If not, then we'll wrap up there. Thank you so much, Vincent.
Thank you.
We'll get started with the next talk in just a few minutes. we'll get started with the next talk here with Jaihao Sun with a talk entitled Decentralized AI. Oh, I'm sorry. Towards Decentralized Machine Learning. Cheers.
All right. Hey, thanks everyone. My name is Jiahao Sun, founder and CEO of Flock. Sorry, just after a break, so I think people want to settle down a bit. So I'll start with some questions like, how many of you guys here have used LLMs? Like, raise your hand. Yeah, everyone did, right? It's now like a routine for everyone, right? Even for a simple email, we will just run through a grammar check. Now everyone become native speaker. So how many of you guys have trained LLM on your own, or even like fine-tune it? Cool, yeah, not many people. And how many of you have actually trained it on another people's GPU? Nope. Or how many of you have trained or fine-tuned an LLM on other people's data? Right, yeah, it sounds even strange, right? But this is actually what we're trying to achieve, a decentralized AI landscape, or actually an end-to-end mechanism for people to actually can use any infrastructure, any data they can get from the community, while we still preserve the privacy to make sure like nothing's leaked, but we can still build on top of other, let's say, that other data sources or other compute infrastructures to make this. So that's what we're talking about as decentralized AI in practice, meaning that we have it out now. So the website is just trend.flock.io, where actually you can do it right now for today. I'll just run through a bit how it looks like. So these are some of our collaborators. The whole general Web3 AI landscape. Like many players are now in this whole AI and crypto intersection, right? Because yeah, it's a hot topic. It's like so popular nowadays. We have people who are trying to tackle the compute, like Fran Jensen from UK as well, and also for decentralized training. I think everyone knows BitTensor, and well, some of you maybe know Flock already. And also people trying to do the inferencing like Retro, Ezekiel, or and also for applications where David was just here for all us, right? And Morphosis and some of our other friends. So yeah, this is a big landscape. Basically, that's the whole spectrum of the let's say what we call the production line, right? From compute to where you're going to do training, to how you're going to inference your data, and to how you wrap it into a product where everyone else can use it. So that's the whole of it. Why actually we need this? Why do we need decentralized training, right? Because centralized models are too centralized, of course. So if you are going to train a virtual assistant that requires you to give all of your data to a third party, that'll be quite scary, right? Which I think yesterday Microsoft launched this new feature on Copilot, where if you're using Windows machines right now, they look into all your details, and they can help you to do suggestions on all the moves. Even when you are playing a game, you ask it, how do I do attack next? He'll tell you, okay, press A or press W. So it sounds scary, right? But it's like the control is essential. So yes, they can claim that they don't transfer your data back, but there's no way to prove they didn't, right? There's always this concern about this, first of all. Secondly, of course, there's poor compensation for data. We all know that once GPT become a hype, suddenly Reddit choose to limit their API calls now, right? And also Twitter as well, everyone knows. You have to pay $5,000 per month to actually get a decent API calls. So just because GPT in the early days, they just take advantage of all this free data, they put everything together, and then eventually, okay, Elon Musk figured out, oh, you are taking advantage of my data. Now I'm going to build my own Grok. So also the risk of biased models, which I guess we heard the news about Gemini's scandal. And also, Simon Pichai had apologized as well, because those models are centralized and it's evaluated by a group of centralized people, and they might have their own polar of their views, right? Which are actually delivering a model that's aligned with their own values, but it's not the same for every corner of the world. So You probably heard like many of the people on Twitter like recently. There's a hype that everyone just posts, and that's me. So post like I resigned from OpenAI to build something else, right? Something decentralized. So yeah, So that's basically the voices from the community that they want something that they can control. That's controlled by the whole community. So that's what Flock trying to bring. The way that we do it is we have we basically so Flock itself is it's a combination of federated learning and blockchain Flock. So yeah, if you're in London, I also do stand-up comedian myself. That's why I like puns. So what we do is there's a traceable contribution, of course, because all the transactions of the training and the model contributions on chain that you can see, okay, if there's only like 100 transactions to that model finally being fine-tuned, right, and I contributed 3 of them, so of course that's 3% of my contribution. That's easily to trace and traceable. And also there's on-chain incentivization where, well, that's the biggest thing of crypto, right? So before, if you are contributing to an open source project, it's not clear now how you're gonna repay from it, get some pay from it. Maybe just show off your status on a GitHub, Hugging Face or Kaggle, and hopefully you can get a job in Google to get higher paid. But that's the only exit for all this open source engineers before, right? But now there's some direct financial impacts. And also, all this gives into our specialized models for the diverse community. So it's not trained by us. We can't see any of the data or any of the models. It's all just governed and evaluated by each different community. So they have their own model. They can build it. So how the whole framework works like so. There's 4 different roles currently, well, actually 3 different roles for the trainers. So there's task creators. Those are our collaborators who are trying to build up a business case to post up a task on Flock. Then they can define their desired models. And there are training nodes. Those are actually the builders in the community who are trying to build models to solve those problems, and also validators. So that's an important structure or important role in our whole Flock system, where they help the whole system to govern whether the training results from any training algorithms are accurate, or are they faking the result, or are they cheating the result. And also eventually the end users who actually the users going to be using those bots or those AI agents or those algorithms, right? Either it's a chatbot that you're going to chat with, or it's like a medical consultancy application, which is actually a real case in our platform right now to be resold to another consultancy company. So there's a real value coming in and from different industry collaborators, both Web 2 and Web 3. So this is how the structure, how it works. Basically, the data stays local. As I said, so the reason we use federated learning. So federated learning is not something like very hard to understand or very old. It's actually debuted maybe 2017 by Google. Everyone nowadays who are using Google phones, actually you are using federated learning already. So Google is using it to predict your typing habits, like what's my next word based on the words I'm typing down already, right? So, but there's always a risk where, it's controlled by a central entity, and they might, if they want, they might get your raw data back. So there's no governance over it. That's also why, if it's so secure, why not Apple join this Google's federated learning training? So we have a bigger user basis and a bigger databases to train the model, right? Nah, they are not going to do that. So that's why we want blockchain to join this federated learning training. So everyone or every trainer in the community, they form this consensus governance. So no one in the middle actually see anything. So it's all has to go through the whole community base. We published papers on this, like our first paper on NeurIPS 2022, and then several following up papers on IEEE transaction AI and the TBD. Oh, TBD is the title. Transaction on big data. It's not TBD. Right. So That's the base layer. So your data stays local. The only thing changes is the modal gradients, basically the changes of the gradients that can pass around, and you don't have to have your data sent over to any third party. It's always local. And the middle layer is what we call the AI layer. AI layer are the ones where we actually collaborate all these roles together. The ones who create the tasks, the ones who are training those models, and the ones who are serving those models. And on this whole AI layer, we will work with our collaborators, either those who provide compute or those who provide distributed data storage, and then eventually the blockchain layer. That's for the whole security of the whole system. So the staking, the consensus, and the incentive to make sure that it's well governed. And also we have the staking mechanism, not for the financial way, but for the governance ways that you have to put down something, or some of the FML, let's say the token name, and then to join the training. So if you are not playing good, you are going to be slashed. But if you are always good, you'll get those incentives. So for good players, let's say good as a simple term, you'll always get resources to join next tasks or the new training opportunities. Or if you are playing bad, you'll be slashed out and you will run out of your gas, basically. So you can't join any more training anymore. That's basically how it works. Yeah, so so there's supposed to be a live demo, but we don't have that facility today here. So I just got some screenshots. So the platform is out already, and we're already having a great community support. And there's going to be a big announcement also with our biggest node operation collaborator, which is also the world's first. I'm currently still under embargo. It will release 6 p.m. today. Actually, it's PT 10 a.m. So yeah, you will know the name a bit later. And so how the platform works is we have those tasks. Basically, those tasks will be generated. It's either, as I mentioned, right, either a bot or a large language model related task, or even not large language model related task, which we did before with our partners in medical area where they do glucose monitoring, but using Flock as a secure way, so they don't have to send their patient's data anywhere else. We can use this to do even cross-jurisdiction training because all data stays local. So those tasks will be published here, and then participants will join the training. They can either choose to become a validator, means that they don't need to do a lot of work. They just need to put on some FML tokens and leave it there, waiting for other people's results, and then to validate, to check the result whether it's getting better for the metrics, right? That's an easy job. And also you can choose to be the training nodes, by which training nodes means those who can join the training and provide their models, either change it from a base model or from some models they've created themselves, basically, to contribute to this specific task. And then those models will compete each other, maybe 10 of them, 100 of them will compete. Whoever gets the best will receive the highest incentives on the whole system. So yeah, there's no financial efforts in terms of the staking thing. So I know when I talk to people like you have to stake to join the training, they feel like, oh, are we going to pay in ETH or something? Nah, it's like there's no financial staking that you have to do. It's just for the whole system's testing and governance. It's just for this system itself. What's the next steps? So basically, we currently have our single node training, meaning that you can run it on your own single nodes. And in the future, there will be more features rolling out. For example, the federated learning closed beta, meaning that we can have those federated learning agents downloaded or installed on your client basis, so they can get secure that their data always stays local. And then you can use those, by use I mean stays local, but you can use those data for training purposes. And we will also have our white paper live. We actually have it already, but then my team told me like it's too academical. Let's make it easier to understand. So we're just like decomposing it now to make sure it reads smoothly. And and moving forward, our task creation will be open to almost everyone. So it's going to be decentralized. So if you have a task yourself, you want to build a model for yourself, you can just put up a task, leave it on Flock, and then wait for the community to contribute together. And yeah, that's pretty much it. So how to get involved? Yeah, whitelist is here. You can scan the QR code. You can actually yeah, check all our socials, and also yeah, join the whitelist. You don't. We are currently just running our second phase, so we might open up the whitelist very soon. But of course, the early adopters will have higher incentives if you are there's less competition, let's say, in the whole ecosystem right now, right? So yeah, that's us. And also for some of the models which are already live, you can check it on beta.flock.io. So with our collaborators, like those for those GPTs for those projects and those medical use cases, they're all online here. And yeah, I think that's pretty much it. And that's our model. We are scaling the decentralized AI, and which is created by communities and for communities. Right? Any questions?
Thank you so much, Jai-Hao. We have a few minutes for questions. If not, we'll wrap it up there, and we'll get started in a few minutes. Thank you so much, Jai-Hao.
Yeah, yeah. And also those academic papers, they are all on this link as well. So if you want to check it out. Yeah, thank you.
Alrighty, this is the last talk for this session, and it's a talk from Evan Griffiths from the Gnosis Labs entitled Building the Autonomous AI Agent Economy.
Thank you. Where was my walk-on music, John? Eye of the Tiger, I thought we agreed. Okay. Hey guys, so I'm Evan, I'm an LLM engineer at Gnosis, and this is a presentation on building the autonomous AI agent economy on Gnosis chain. So, yeah, Gnosis, towards the end of last year, started an AI effort. It was a team of LLM engineers, and with the remit of that being to build proof of concept use cases for the agent economy on Gnosis chain. So agents being users of decentralized applications, competing for finite resources, and then the kind of emergent result of that being what we call the agent economy. And the kind of goal of this, apart from being kind of a research effort, is to onboard more users to Gnosis chain where users are agents, with the strong belief being that agents can be a large proportion of the user base of Gnosis chain going forward. So just for some context, where does this sit in the kind of AI Web3 intersection? So you've got kind of a division between these two things as far as I see it. First being an augmentation of the traditional AI stack with Web3 technologies, so things like zkML, decentralized compute. And then on the other side of the coin, you adding AI to Web3 applications. And that can be to help humans interact with the blockchain by using natural language instead of calling smart contracts, or having AI as a player in the game in itself. And this area is the kind of thing that we're focusing on in the team, and that's what we're going to be talking about here. Next slide. So, yeah, first question, where will autonomous agents be transacting on chain? I don't know about you guys. In my Twitter inbox, I'm getting daily messages about all these easy ways you can make money on chain. So at a high level, agents will be acting wherever they can make money. Lots of opportunities, I'm sure. But generally, there are kind of two areas where we see them being particularly well suited. And these are where having general intelligence beats out these kind of use cases where you can achieve the same kind of goal by ruthless scripting techniques. And the second is where the human general intelligence isn't being applied because the incentives aren't there for humans, because they have finite time. Agents don't kind of have those same kind of constraints. So with those kind of things in mind, the first proof of concept, the first use case that we took was prediction markets. If you were here for David's talk, you'll see some overlap between these presentations, but here we'll have kind of more of a engineer's practical guide. So prediction markets, for those of you who don't know, as an example of a prediction market there on the screen, the URL for this platform is there, AI Omen, where any user can go and post a question about a future event. So there's an example one here with a yes or no outcome, and then other users of this prediction market can purchase tokens in the outcomes, and placing a bet essentially. The market creator provides liquidity to incentivize this because there's value to them in knowing the answer of that question, and users want to bet because if they do a good job of it, then they have an incentive because their tokens end up having some value. The people who fail, their tokens become worth nothing. So the net effect of this is kind of an incentivization structure for the truth seeking. So this was the use case we chose. Let's go through some additional. So this use case satisfies the constraints we saw on the earlier slide. But if you think about what you need to be a good participant in prediction markets, this is a set of things here which again mean that agents are very well suited to this task. So modern LLMs have very broad but also deep knowledge base. They're good at, if you want to make a prediction on some future event, you need to have access to real-time information. LLMs can do this research, and when equipped with the right tools, do this research, and then are good at kind of aggregating this unstructured data to make a prediction. And then that final point we addressed already is there. Lots of times in prediction markets, humans don't have a sufficient incentive because the liquidity might not be very large, but agents don't have such a strong preference on that, and they can work for cheaper. Okay, cool. So we've picked our use case. Let's build our agent to act in this economy. So what do we mean by an agent? If you're familiar with the old kind of term of agent, this was something where used in reinforcement learning, where you have some parameterized model acting in some environment. It would receive some reward as a feedback, which would use to update its parameters accordingly. This is kind of not what we mean really when we talk about agents these days. We're talking about some system built on top of LLMs. And you have these kind of lots of Python libraries, a plethora of Python libraries that you can use these days to build these kind of systems which build on top of LLMs with some additional features. So let's go over these features. So LLM is the kind of core component of an agent, and that's used for the kind of general intelligence aspect. But then additionally, if it's going to be agentic, it needs to have tools that allow it to act in the real world. So for our prediction market, it's going to be doing some off-chain actions like web search and scrape, and then doing some on-chain actions. So this is our decentralized application, which is interacting with via Web3 library functions. Next, it's got some memory component. So our agent is stateful. It's going to be acting over a long period of time. It's going to remember, I didn't do so well when I bet on this market 3 weeks ago. Maybe I should consider how I research this topic in the future. And additionally, memory for overcoming context limitations of LLMs. And finally, for control logic, so you start with some kind of overall goal. I want to make money in this prediction markets. Breaking that down into sub-goals, managing the progress through a kind of run of the agent. And that's kind of what we call control logic. Okay, so let's illustrate this with a simple example. So here's just a snippet from LangChain, where we're just calling our LLM with the question, will it rain in Berlin tomorrow? If you do this, you run this, you'll get some response. I'm sorry, as an AI, I don't have real-time data access. So this is no use for our prediction market use case. It doesn't have any agency. So let's add some agency. So another snippet where we're using the LangChain agent library now. And you'll see we're initializing an agent. And we're passing in some arguments which look just like those features that we identified on the earlier slide. So we're adding a search tool, which allows it to go and scrape the web. And we're adding some control logic to say, kind of have this back and forth conversation like you do with ChatGPT, except both sides of the conversation are managed by the agent. So now when you run it, you get much more useful information. It goes and recognizes it can't access, it doesn't know the answer, so it goes and searches the web, and then you get an answer. There is a significant chance of rain in Berlin tomorrow. All right, so sorry to be the bearer of bad news. Bring an umbrella. Don't say I didn't tell you so. Okay, right, so we've got our agent, the rough components we want to give it, and now there's a kind of big design consideration as engineers that we need to consider when building this agent, which is how much autonomy we want to give it. And this is a spectrum. It's not, so it's a design decision for the engineer. So take this top example, this code snippet. you've got a kind of set of functions which you need to be able to run to be a participant in the prediction market. So you're picking a market, you're doing some research, you're making the prediction. These things can each involve calls to the language model. But in this top example, this kind of execution logic is hard-coded. There's limited autonomy in this case. Then you can look at the second example, where you're now giving these functions as tools to the agent, and you're handing over the decision of how to call them, what order, how frequently, to the model. And then you can even imagine another case where instead of hard coding these tools and kind of statically giving this list to the model, you kind of give it the ability to search a marketplace of tools. And so this kind of adds a new degree of freedom to the agent. But with this kind of extra autonomy that the agent now has, there are trade-offs. And the main two being reliability and price, because the more the kind of agent has to think in the sense of generating tokens and reflecting on its choices, the more expensive that is, and then the more chance there is that the agent will go off course, make some mistakes, and so on. So that's something to consider. But we'll pick some point on that spectrum. We've now built our agent, and now the next kind of consideration that I want to talk about is observability and metrics. So this is a new kind of consideration for building agents that we didn't have to really think about when building other applications, because there's now this kind of fuzzy world of when you have a program previously, it kind of either works or it doesn't, and now there's a bit more kind of fuzziness in the ability to evaluate the model, where it's more of a question of like how well does it work, and there's like your kind of degree of uncertainty or like degree of non-determinism that's been spoken about before. So we kind of look for lower level metrics that we can evaluate our model on and produce kind of benchmarks before we deploy our agent to kind of see how it's doing. So in the prediction market use case specifically, the kind of metrics that we're interested in, how good is our prediction relative to the correct answer, or how good, and that's kind of measured after the fact, like you only know that once the market's closed. But maybe a proxy that we can use to kind of make benchmarking easier a priori is to compare our agent's prediction with some crowd prediction on existing popular prediction markets like Manifold or Polywrap. Some other considerations, more general observability and metrics considerations. This is the kind of final thing I'd like to talk about is logging and debugging of the agent. As I said, this is a kind of fuzziness for deployed agents, where the kind of output is natural language as opposed to like easy to pinpoint right or wrong results. And a great way to handle that is to use some kind of dashboard. There are these libraries which kind of really help with that by just adding a callback to your OpenAI API call, and then you kind of get nice execution traces of your agent, where you can see kind of which tools it called, how frequently, the kind of length of each step, and the number of tokens required. And that's great for debugging and optimization. Then, because our agent we're kind of sending it away with some resources in terms of a crypto wallet, and we're expecting it to do some work for us. There's a cost associated with it in terms of tokens and perhaps other API calls. And then the key metric is it kind of self-sustaining in the sense that the profit that it's generating is the sum of those two costs plus some extra. And then the final thing is also another kind of fuzzy concept, but if we've set our agent up with sufficient or degree of autonomy, then it has the capacity to learn over time. And that's by managing its context window to kind of prompt itself in better ways to produce better outcomes, and also to select better tools in a way that, again, produce better outcomes. And so that's another thing that you can look for in your agent. Okay, great. That's pretty much everything I wanted to talk about. Lastly, where to find us. So we have we have a June dashboard for all of our deployed agents that are working on the prediction markets use case, full of lots of dense information. You can check it out there. We have a couple Streamlit apps associated with our code bases, which are all open, that are kind of fun to play around with, and to kind of test out how our agent runs through a kind of prediction and the kind of function calling aspect, and kind of playing around with kind of agents that are currently deployed. And we have a couple GitHub repos, which again are all open, which feel free to take a look at and build your own prediction market agent if you'd like from our tooling repo. And we've got some examples as well. Okay, I think that's everything from me. Thank you very much. I've been told that John has been pulled off for some other engagement, so I'm going to manage the Q&A. So I guess, any questions, please, hands up. We've got a question over here.
Thank you. I want to ask about the alignment of these agents with humans' goal. Like, let's say you start off these agents with a $10, and let's say the agent becomes a millionaire, and they just keep making money. And what is the benefit for humanity of, is that goal aligned? Is it like making the predictions more efficient to help humanity to gain benefit from it? Or what other sense other than consuming energy can it have?
Yeah, sure. So I guess the agent is kind of given some, is deployed by some owner, so it doesn't kind of appear out of thin air. Someone's going to deploy the agent on their cloud or something like that, or in some kind of decentralized manner. And they're going to fund that agent with some crypto. And the agent is kind of being put to work on behalf of that owner. So it's aligned in the sense that the creator of the agent is giving it some goal to kind of set it going. Kind of as I was talking about in the presentation, with the kind of sufficient autonomy, then I guess there's an element of to what extent does it stay within these kind of guardrails set by the creator of the agent. But yeah, in terms of benefit to humanity, well, it benefits the owner if it is a sustainable entity. It's not essentially costing the deployment isn't kind of having a net loss, if that answers your question. Send it off and throw away the key. I mean, I suppose a kind of key management is a kind of separate topic, but in this example, we're deploying the agents with a key and monitoring the performance based on that key. So, thanks.
Hi.
Hey.
I think we are always considering that this future with a lot of agents are going to be the end game, and then everyone will have an agent, and everything will be, based on agents' actions. But I'm also considering that they might fail, maybe a few times, and I'm just thinking, like, what are the possible risks on that, and what could make an agent fail?
Sure. I guess I can speak from personal experience of our work that we've done so far in the team. Yes, they at the moment aren't very good, and therefore in their current form aren't anything to be scared about. They're something that to be developed to the point where they're useful. So I guess for the time being, it's hard to say how long for. Failure is kind of inevitable, and there's, I guess, anyone who's developing an agent project is like just eating the cost of OpenAI credits or whichever provider they're using, in the hope that it becomes at least an order of magnitude like cheaper to run their agent, and the agent's capabilities improve a lot more to the point where they're being useful, like they're actually kind of making money or writing good code, doing good PRs, that kind of thing. Cool, thanks.
Hi, so I think you answered the question because I wanted to ask if it works
Okay.
and does it produce profit, but maybe, so what's your expectations when it's gonna to be working better than humans?
Yeah, sure. So, yeah, to answer that question, I guess our deployed agents are currently profiting in the sense that they're like just taking the prediction market scenario of placing a bet, getting some returns on it, and making more correct bets than incorrect bets. So they're kind of doing the forecasting okay, but then considering the costs of the kind of LLM calls and the kind of additional APIs that they're having to kind of pay for to be able to operate, there's significant net loss. And I think it's going to be a kind of a gradual improvement with like small step changes when new models are released. So I guess everyone who's running an agent, depending on GPT-4, is going to wait for GPT-5 and then switch the flag in their agent, and then there's a kind of moment of to what extent does that alone kind of add? Yeah, sure. I mean, so this prediction market use case is kind of constrained or it's slightly artificial in the sense that like there's not a organic user base kind of creating the markets and like other users placing bets. So there's a kind of artificial environment in that a lot of the market creation is being managed by agents, the market resolution is being managed by agents. So we're not doing this as a kind of like side project to profit from prediction markets. It's like a proof of concept, kind of a research application in that sense. Why you don't want to make money? Right. Okay. We'll double the bets and we'll retire from our day jobs. Yeah. Okay. Thanks. Another question?
Great talk.
Thanks.
Actually, have you thought about the paperclip problem for pushing this to the limit? Like the agent predict the market. At some point, the agent will try to decide the market.
Yeah, sure. So in the prediction market case, the kind of incentives are set up so that if I get your question correctly, if the agents are kind of placing non-truth-seeking bets to try and influence the result of the market, so that the market, so it says, yes, Trump is 100% going to win the next election, and then people go, oh wow, and that's going to influence other people's behavior. That kind of malicious intent.
Even more than that, for example, let's say something is going to happen, and it's going to do some terrorist attack or some crazy thing that like changes the outcome.
Yeah, sure. So I suppose in this example, your agent has been built such that it has capabilities of prediction, of participating in prediction markets and capabilities in warfare. And I guess it's maybe up to the...
Let me do an example like COVID.
Yeah, sure.
I mean, the market, if you knew that if you knew that COVID was happening, you could have shorted the market. And the outcome from that could be higher. The incentive could be to actually do that.
Yeah.
So I wonder if an agent could do something like that, push into the paperclip.
Yeah, right.
Extreme.
I guess that's like a consideration maybe beyond the scope of this presentation in terms of like power being gained by super intelligent AI. For the moment, luckily we haven't got that problem. So thank you very much. Cool. Thank you very much, guys.
Thank you. We're going to make a 30-minute pause, and then we'll continue with other presentations.
Do I go over there? Do you?
Hello, everyone. Thank you for joining the DappCon. My name is Arman. I'm a moderator on this session. So I'm very excited to introduce Jordan from Stakewise. And he's going to be talk about a future of liquid staking on Gnosis chain. So please give Jordan a warm welcome, please.
Alrighty, hey guys. Okay, cool. So thanks for joining me today, and congratulations on making it up the stairs. That was the first challenge. So today I'm going to look at and discuss liquid staking on Gnosis. I'll first touch upon what the landscape has looked like for the past couple of years, and then specifically looking what you can do when we launch Stakewise v3. And it's going live imminently. It's currently in the final stages of audits, so hoping to go live early June. So first off, what is Stakewise? So Stakewise has been live on Gnosis since early 2022. It was the first non-custodial liquid staking solution on Ethereum. It launched in 21, and so we deployed it also on Gnosis in 22. And the goal of Stakewise, as it currently stands on Gnosis, is to completely reduce the barriers to entry for anyone to earn a yield or to effectively stake their GNO. So we have a large staking pool. Anyone can stake their assets into that pool. There's no minimum staking amount. And so it reduces the economic barriers to staking. Albeit on Gnosis, that's not a massive thing, but it also reduces the technical barriers to staking. We have 3 commercial node operators, Crypto Manufacture, ourselves, Stakewise Labs, and Fanoa, who then stake the capital on our users' behalves. But it's not just that, it's also a liquid staking solution. I'm sure everyone's familiar with liquid staking right now, but there's a bit of a nuance with Stakewise as it currently exists on Gnosis, and that is the dual token model which we have in place. So effectively, when you stake into the pool, you receive SGNO, that is the main liquid staking token, and that represents the staked principal, and then all the rewards accrue in RGNO. Both of these tokens are effectively soft-pegged one-to-one with GNO. And obviously, as a liquid staking protocol, you can then, this has been super valuable before withdrawals were enabled on Gnosis to allow people to exit liquidity. Obviously, withdrawals are now enabled, but it still allows people to go and access DeFi with their staked capital. So having these liquid staking tokens are still incredibly valuable. And so this solution has been live now for 2 years, and it was incredibly successful. It was actually arguably too successful. We had about 40% of the staked GNO delegated to Stakewise at one point, which, as we all know, can be problematic. And so we actually decided alongside the Gnosis Foundation to stop spinning up validators. And so today, we haven't spun up a validator that I'm aware of for over a year now. We still have about 75,000 GNO staked with us, and thankfully that is no longer 40%. It is around 33%. It's still very close to certainly the maximum we want it to be at this point. But of that 75,000, only about half of it is staked. And so actually one of the consequences of not spinning up these validators is that the staking yield is currently about half of what it should be on Stakewise. And the trade-off there is that the users get the LSTs. Now, it's not a perfect fit right now. We need to fix things. And so this is where Stakewise v3 comes in. So a quick introduction to Stakewise v3. So whereas the current version of Stakewise, arguably v2, is a single staking pool with a permissioned node operator set, the best way to think about Stakewise v3 is that we've completely white-labeled all of our smart contract infrastructure to allow any entity to offer their own staking as a service. So we currently have our staking pool, but when v3 goes live, we will allow anybody to set up their own staking pool in a fully permissionless fashion. And this is the layer we call vaults. Each staking pool is a vault. And these vaults, these smart contracts, essentially allow anyone to offer non-custodial, trustless GNO staking. And they also automate pretty much everything to do with GNO staking, other than actually running the validators themselves. So these vaults can accept GNO in any size. They pool the capital. They automatically register validators. They automatically exit validators. They handle the fee distribution from the staking rewards to the node operators. It's a very complete package solution. It also has other features like tokenization, so you can launch your own LST if you really wanted to go down that route. It has auto-compounding. You can make them public or private. They're very flexible tools, and that is exactly the phrase we use actually internally. Is they're a toolkit. We have node operators on the Ethereum side who have been offering staking for years, but when V3 went live, they have moved completely over to running their staking operations within the Vaults architecture, because it just helps streamline their processes. And the best part about it actually is that we don't charge for this part of the protocol. The Vaults architecture is completely free to use. We see it as a public good. And actually a good analogy is we see Vaults almost as like the Gnosis safe for staking, which is very relevant here today. So that's Vaults. And what's important to mention is that each Vault is fully isolated. They're unique smart contracts. They're completely unique staking pools. And under the hood, we are very flexible on what the node configuration looks like. And I'll go into that in a little bit further shortly. But we're still a liquid staking protocol when V3 goes live. And we'll be launching a new LST called OSGNO, Over-Collateralized Staked GNO. A bit of a mouthful, but it is what it is. But it's the same liquid staking token which sits on top of the entire Vaults ecosystem. And what it means is that anybody who stakes into a pool that's deployed on Stakewise can make their stake liquid. Now, there's going to be a subset of node operators that we have effectively permissioned as Stakewise DAO, and whenever they are running in a vault, they will allow users to mint the token one-to-one, 100% capital efficiency. There will be then another subset of vaults, which are the fully permissionless vaults, where we are implementing a maximum minting cap on OSGNO at 90%. So what does that mean in practice? It means that any node operator can come to Stakewise, deploy a vault, offer staking as a service to their friends, their clients, whatever you want to call them, and those users will be able to access OSGNO. If I stake, let's say, 10 GNO into one of these staking pools, I will then be able to mint 9 OSGNO to make it liquid. We don't require any bonding or collateral from node operators, and so in order to protect against malicious actors, slashing, etc., it is that 10% capital buffer in the OSGNO over-collateralization that provides that protection. And the most important thing about this token is that we, as Stakewise, in partnership with Karpathy and the other key partners in the Gnosis network, will be helping provide the liquidity and provide the integrations for this token. So in short, Stakewise v3 provides the toolkit for anyone to offer trustless, non-custodial staking, and we also have a ready-made liquid staking ecosystem through OSGNO for their users to access. It's a really powerful protocol. It's been live on ETH now for several months, and yeah, there's some really interesting use cases for this, which I'll also come on to. So just quickly looking at what the transition from Stakewise as it currently stands on Gnosis to v3, and it's actually very simple. It is purely an accounting transition, a swap from the existing tokens to the new token. There is nothing going on under the hood in terms of all the validators will remain staked in the current, and they'll essentially migrate over to the staking pool or vault, which will then be on Stakewise v3. So the current staking pool will become the first vault on Stakewise v3. Again, there's no actually unstaking and staking going on here. It is purely an accounting transition. And during the migration, users will be able to swap their OSGNO and SGNO and RGNO for their true value, i.e. one-to-one with GNO, into OSGNO. And during that process, the S and R tokens will be burned, and they will ultimately be made redundant eventually when everyone has migrated. It will be a manual migration process. We can't just take people's tokens and do it for them. But if users don't migrate straight away, it's not the end of the world. Your SGNO, if you hold SGNO, you'll continue earning staking rewards just like you are today. But if you want to either withdraw or access the V3 ecosystem, then you'll need to go through this transition step. But the transition on Ethereum went through very smoothly. It shouldn't be a problem. So, yeah, famous last words. So what does Stakewise V3 actually bring to Gnosis? Now, firstly, withdrawals. We are very conscious that Gnosis network enabled withdrawals several months ago now, and our users have had to put up with secondary market liquidity for exiting. This is not ideal, and we are very appreciative of our community standing by us whilst we get the development done for enabling true withdrawals. And so just after migrating, users will have the chance to submit their OSGNO for unstaking natively. There will obviously be a short queue based on the withdrawal queue from the network, but fundamentally, it would now be a fully functioning staking solution, including withdrawals. There will also, the simple one-click staking solution will remain in place. So as I mentioned, the current Stakewise pool will become Genesis Vault, effectively one of the vaults, and that will remain in place. And it allows that simple one-click staking from GNO into OSGNO, where users don't want to have to run their own infrastructure, etc. So that is going to remain in place. But the next two slides are really where the V3 kind of comes alive. And the next one is, we're going to enable a whole new ecosystem of staking businesses. We have, on Ethereum, loads of different entities that have now launched staking solutions through Stakewise. Node operators are the obvious choice here, but it is much more than just node operators. It can be wallets, custodians, exchanges, etc. As mentioned on the slide, that any entity that wants to offer staking as a service can now do it. If you're a wallet, for example, so on ETH we have a wallet that's launching their own LST. They've partnered with a commercial operator. You still need to have a node operator staking the capital on your behalf, but this wallet is able to launch their own staking pool, connect their node operator, and have the whole solution pretty much run automatically for their wallet. And so it's going to enable wallets to offer true native pooled and or liquid staking to their users on Gnosis chain. And the same goes for custodians and exchanges. These solutions tend to be a little bit more, well, they are more regulated, and this is where the private vault functionality really comes in handy. So for example, on mainnet, we have exchanges that are launching a private vault where only their hot wallets are whitelisted, are allowed to stake. This makes sure they can keep all the capital in the staking solution completely ring-fenced. It's only their users' capital that is staked. And that still allows them to offer this staking solution in a regulatory compliant manner. And on the custodian side, we have custodians who are doing a similar thing, but we also can go one step further and offer private pools on a per client basis. And so if you really need to cater towards very strict institutions who cannot be commingling assets, then again, you can still use a vaults architecture, but just do it on a per client basis. And even though there might be just one client staked in a pool, they can still access the LST if they want to. The other one on that list is DeFi projects. We've got a protocol on Ethereum who's launching a solution, and it's hoping to go live in the next couple of weeks, and it will have about 200 node operators from day one. This is a really cool solution, and the majority of those node operators are solo stakers as well. They're actually rocket pool node operators that have created their own little staking syndicate, so to speak, and they'll be launching a DeFi, one of these DeFi protocols' own LST in a few weeks' time. I mention this because it really shows how flexible the vaults can be with the node configuration under the hood. As I mentioned, that one has hundreds of node operators. We have other solutions that have SSV, DVT, SSV and OBOL, the DVT technologies, work out of the box with Stakewise. The smart contracts are completely flexible on the node configuration under the hood. And so it can lead to some really interesting staking configurations. And as I said, open up a whole new ecosystem of businesses offering staking as a service on Gnosis. The last use case is, I would argue, the best. And this is liquid solo staking. It's a narrative that really hasn't caught on yet on Ethereum, but I think Gnosis stands to be a really strong network to pioneer this idea. And it's quite simple. You have solo stakers who make up a significant portion of the Gnosis network, but because they decide to stake on their own nodes and not use a liquid staking solution, they miss out on all the benefits of liquid staking. That's not right. Like, they are the gold standard for decentralization. They should get all the benefits that that anyone using a liquid staking solution gets. And this is what Stakewise v3 provides. So what does it look like? I'm a solo staker. What I will do is I will create a private vault and connect my node to this private vault. So it's my pool, it's my node, and I will stake my GNO onto my node just like I do currently. I will deposit it into the vault, and behind the scenes, I'll be running the Stakewise operator service, and that will automatically register the validators. I remain in full control of my staked capital, but because I have done it through a Stakewise vault, I will then be able to mint OSGNO. It will be at 90%, but what it does mean is that I could be leverage staking. I can go from ETH to from GNO to OSGNO, take that onto Aave, borrow more GNO and leverage stake if I really wanted to go down that route, or I could just use my stake capital to borrow stables or what have you. It really opens up this entire DeFi ecosystem for solo stakers. And we have a package that's going live on DappNode imminently. So again, trying to reduce the barriers to entry, but also on the node operator side as well. So that's essentially everything. As I mentioned, the audits are very, very nearly complete. We've already done one audit. We're just finalizing one more to make sure it is absolutely airtight. But yeah, we are. And in the process, we're already lining up liquidity for OSGNO, integrations for OSGNO, like Aave, Spark, the main protocols that are on Gnosis at the moment will have this token onboarded in a, fingers crossed, a pretty timely manner. And so, yeah, we're going to have this pretty cool ecosystem already built out. And as I mentioned, that liquid solo staking part, whilst we have a lot of business partners that want to be launching their own businesses through Stakewise v3, I think we are going to make a very concerted effort to push and encourage, obviously, more solo staker participation, but also liquid solo staking as well. A couple of links there to stay up to date, but yeah, it should be going live pretty damn soon. And yeah, if you don't hear about it, then we're not doing our job properly. We should be shouting about it. So yeah, thank you very much.
Thank you, Jordan, for very detailed presentation. We have time for a couple of questions. Yeah, please.
There is a maximum of 90% that you can make liquid. But that 90%, 10% seems arbitrary to me. So what is it based on? And could it be customized in the future depending on the risk of the type of staker? And then who would need to customize it? Who would need to decide on it?
Sure. Yeah, so it's not arbitrary. So the 10% originally comes from Ethereum, and the slashing risks. So the average slashing loss on Ethereum right now is about 1.1 Ether. Obviously, you can have correlated slashings, etc., but they are rare, have never happened in scale. And so that 10% capital buffer is enough to protect against those slashing losses. When V3 originally went live on Ethereum, it was just 90% LTV on every single vault. We are going to tweak that, though, so there is some vaults that have 100%, just to kind of make the whole user experience for retail stakers who want a one-click stake, make it much more efficient. But because we have done effectively the development work to make some vaults 100% and others 90%, it does allow us in the future to be much more flexible in effectively what LTV different vaults can have. The problem is that it's very hard to, in a way that we don't KYC users, to keep a system that is fully permissionless, whilst actually being able to say, okay, this node is not malicious, or this node is running XYZ clients, maybe DVT technology, the chances of slashing are reduced. It's actually impossible to do that technically right now. And so we have the framework in place that we can become much more I would like to say inclusive to permissionless node operators, and allowing them to increase their ability to use, like borrow OSGNO effectively. But as it currently stands, it's a technical limitation that's kind of stopping us from allowing us to do that, basically.
Yeah. Will there be some interest you have to pay if you mint OS GNO?
Yes, there will be, and that's the one bit I forgot to mention. So, as I mentioned, on the Vault side, we don't charge a stake-wise. It is purely the node operators or whoever launches that solution that decides the staking fee and ultimately how it's split. So, for example, let's say you're a wallet. You can say, I want to charge my stakers 10%. Half of that goes to the wallet, half of that goes to the node operators. You can split the fee on that Vault level however you please, but ultimately, stake-wise doesn't take any cut from that. Where we do charge is on the liquid staking layer only. And the way it works is we basically charge on Ethereum it's 5%, on Gnosis it's TBD, but it's probably going to be the same. 5% of the staking rewards of the OSGNO token. So it's basically like an interest rate on how much OSGNO a user has minted. Depending on how you stake in this platform, like the liquid token is actually a completely optional layer. And so a node operator could offer staking as a service to users who don't want liquid staking, but they can still do it in vaults for free and run that completely without charge. And their stakers would just pay the fees that the node operator sets. It's only when they decide to mint OSGNO that they would then start paying those OSGNO fees. And on Ethereum, I keep using Ethereum as an example because it's been live for some time now. We have about 100,000 Ether staked overall, but there's only about 35K Ether's worth of ETH minted. And so, 60-odd% of our users are, just natively staking, and they're happy to do that. And this is a theme we've seen across DeFi. Like most of the LSTs in the space, are not used in their majority. They are just a form of, they're just an accounting method in a user's wallet. And so we made it a deliberate effort to make sure that users can abstract that layer away and not pay those fees unless they actually want to liquid stake.
Thank you, Jordan. We are going to... OK. We are going to the next talk.
All good?
Thank you for the participation.
No worries. Thank you, guys.
OK.
I knew I'd forget that.
Next up is Dimitri from Lido, and who will present Lido goes permissionless under the hood to us. Please, warm welcome to Dimitri.
Oh, that's not the first slide. That's the first slide. Now bad. Hello everyone, and today we're gonna talk about the fact that Lido goes permissionless. And you will probably ask, hey, come on, everyone can stake with Lido. Isn't it already permissionless? Technically, yes, but there's two sides of Lido, and the first one is stakers, and the second one is node operators. And from the node operators side, Lido is definitely not permissionless, not at all, only curated operators. But this thing is about to change by the end of this year. And today I will tell you about the most exciting parts, maybe from the technical part, that are under the hood of Lido going permissionless. Let me introduce myself. My name is Dmitry. I've been contributing to Lido since the very beginning of 2022. And since the middle of 2023, me and my small team, we are working on the product called CSM, or Community Staking Module. A module to a staking router that will allow anyone to join Lido as a node operator in a permissionless way with the best possible conditions on the market. But how is it to be permissionless? When we think of permissionless staking in Lido, between Lido contributors, we have a permissionless trilemma in mind. First of all, a permissionless staking solution should be secure. If it is not secure, no one will use it. At the same time, it should be trustless. Because even if, for example, you would let anyone enter without asking for permission, but then would not allow them to exit, and will say, okay, you need to ask for permission to exit, this solution would not be permissionless. And the last but not the least, it should be attractive. We have such a big market at the moment, so many opportunities for node operators to become parts of different protocols, like Stakewise v3, for example, Rocket Pool, you name it. So the solution should be attractive. And the most complicated part that you cannot focus on one thing. You cannot just make it attractive, or you cannot just make it secure. You need to have it all at the same time. So let's try to find out how we tackle these issues with CSM. And we will start with the first aspect, the trustlessness. And as you can see from the slide, the main tool to ensure trustlessness within CSM is EIP 4788. Have any one of you heard of this EIP? Raise your hands. Oh, not that much. Then I'll give you the gist. So you guys probably heard that Ethereum is actually made out of two parts, execution layer and the consensus layer. And the consensus layer is also known as beacon chain. And the weird thing about Ethereum is that before EIP 74788, the only connection that exists was between the beacon chain and execution layer. So from beacon chain, you can access execution layer data, but not vice versa. However, all the DeFi applications, all the smart contracts, they live on the execution layer. And if your DeFi application is a staking protocol, for example, you need to have this information about things going on with validators on the beacon chain. So with EIP 4788, it now became possible, but not in a very straightforward way. So beacon chain data might be represented in a form of a simple Merkle tree. So you can represent any data that ever exists on beacon chain as a Merkle tree. And EIP 4788 allows you not to directly access this data, but to prove that the data provided is indeed a part of the beacon chain data by proving it against the root of the beacon block. So CSM used this feature to prove two facts, validator withdrawals and validator slashings in a permissionless way. So we can stop here now. Okay, we can prove it. Actually, not all the things are that easy, and there's several challenges. The first challenge is when you want to request a beacon block header or beacon block root from the execution layer, you cannot request it by block number. You can only request it by a timestamp, because execution layer could not know beforehand if the slot was missed or not. So it creates a bit of a challenge. You need to operate timestamps, which is not very typical in a blockchain. Second thing is that the data is arranged within this tree concerning so-called G indices, or indices that shows that this particular data is located in this leaf and this particular data is located here. And the problem is that with each hard fork, or with, it can change, maybe not with each, but it tends to change from hard fork to hard fork, meaning that you need to solve this issue somehow, because the data that you rely on might be here, and in the next hard fork, it might be here. The next thing is that you cannot prove simple data, because this proofs might be gamed. You cannot just prove that, okay, in this particular leaf, there's uint. You can do it, but in most cases, it would either be useless or it might be gameable. And the last, and probably the main issue, is that roots of the blocks are only available for 27 hours. So if you want to prove some event that is far, far back, you cannot do it explicitly. Sounds like there should be emoji here, but it disappeared. Anyway, we have solutions for it. So first of all, instead of proving instead of using these timestamps and trying to catch the correct block and guess if this is the correct block on the correct timestamp, we prove beacon block header first to be sure that we are dealing with the correct block. Second, we maintain a trusted storage for the G indices so that with any hard fork, when new G indices arrive, we can be sure that both previous data and the new data can be accepted in a trustless way. The next thing is that instead of proving simple data types, like for example, validator balance on a withdrawal or the fact of the validator being slashed, we prove the whole validator structure instead, so that we can be sure that this is indeed the correct validator structure and all the data is included. Why it is important? Because it's way harder to fake the data if it is a structure than if it is a simple data type. And the last, even though these block headers are available only for 27 hours, there's still such a thing as historical accumulators, namely historical summaries, that might be used to prove the data against it. Okay, so that was pretty boring, I know. But if you want to get it even more boring and get a hands-on experience with 4788, make sure to scan the QR code. There's a very handy example here. And to be honest, we spent a lot of time with the team trying to figure out all the peculiarities and to find some useful examples. So there's one, definitely check it out. Moving on, the next aspect, security. And security in CSM is achieved by the thing called bond, but not a regular bond, but a bond with the curves, with the special curves. But before we start talking about special curves, let's first talk about the bond in general. So in the case of a vanilla staking, all the stake associated with the validator is just a single pile. It might be either provided by the validator itself or by a third party, but there's no split in it. With CSM, validator's stake is split into two parts: delegated stake and node operator's bond. And the main difference between them is that node operator's bond is slashed first. And only when there's no node operator's bond, the delegated stake is slashed. So it's just a security tool to ensure that node operator will behave okay, or even better than okay, and will not put user funds at risk because he also have some skin in the game. Now let's take a look at an example. Imagine you have a node operator within CSM operating 4 validators. Each of them has bond, each of them has delegated part of stake. Now something bad happening. For example, huge slashing, but for just a single, for the very first validator, or a huge MEV has been stolen by this validator. And the amount of penalty in this case exceeds the amount of bond. What we will see? We will see that now it's not only validator's bond which is affected by this penalty, but also delegated stake. However, we still have these 3 validators with the bond provided by the same node operator that remained untouched. That doesn't seem to be okay. So let's try to fix it. Instead of using a separate bond for a separate validator, we can now use a concept of a continuous bond. So if you have 10 validators or 4 validators, like in this example, all the bond provided will be treated as a single security collateral. And in this case, even if a single penalty exceeds the amount of bond required for a single validator, user funds would still be out of risk. So it drastically reduces the risk. But can we reduce this risk further and at the same time make it appealing for the node operators to use this technology? Let's try to think about it a bit. First of all, major penalties are associated with the block propose duty. So there's basically 2 things. When you propose a block, you can either steal MEV or execution layer rewards from the liquid staking protocol you operate with, or you can be a subject of a proposer slashing if you, for example, propose 2 different blocks. However, slashings are likely to be correlated for a single operator because Slashing might also happen due to double attestation. And if you run, for example, this 4 validators on a single machine and you have a backup machine, and for some reason your backup machine launches without you knowing, and now both of them perform different attestations, and most likely all of your validators are slashed. However, even though the slashings are likely to be correlated for a single operator, there are very few operators in the whole world, all of them are absolute professionals, who are capable of flipping the midterm penalty, the most dangerous penalty within Ethereum slashing, from 0 ETH to 1 ETH. Meaning that for absolute majority of CSM operators, or I would say for most of them, for all of them, even if the slashing will be correlated, the midterm penalty would still be 0, and there would be no difference in absolute values between individual and correlated slashing. So what are we going to do with all this information? With all this information, we can introduce these curves, our concept of nonlinear bond. So the bond would not only be a common feature for the node operator, so no matter how many validators you have, all the bond is used as a single collateral, but also the bond will be reduced the more validators you have, because this common pile will be bigger and bigger, and you can add a bit less, a bit less, a bit less. And the final value here would definitely be the minimal value required to cover for the minimal possible slashing penalty. At the end of the day, it makes it beneficial for both. It makes it way more secure for stakers and pretty attractive for node operators. Okay, let's move on to the final part, attractiveness. And that's the trickiest part, actually, because with all these solutions on the market, with things like vaults from StakeWise, with cool features provided by Rocket Pool, with amazing features provided by other staking providers, it is really hard to compete, and it is really hard to offer something new. But we do believe that CSM Performance Oracle is indeed one of the unique features that might be a game changer in terms of attractiveness. But before we dive into the Performance Oracle itself, let's first talk about why we need it. And now let's take a look at rewards. Rewards for Ethereum validators actually came from 2 sources. The first one is simple beacon chain rewards. So you fulfill your validator duties, you get your rewards in a form of reward skimming. All of them are accumulated on LIDA withdrawal credentials, a single contract for all LIDA validators. At the same time, when you got lucky enough to produce a block, you will also get some part of execution layer rewards, either only priority fees, or in case of using MEV boost, you will also get MEV rewards. And all of them would still land at the same vault within the same huge pile. And the second part is actually really volatile. So if this vault was only for you, you would see the graph of the balance of this vault like slightly changing, increase, slightly changing, increase. Or maybe no increase because you were not lucky enough and slightly change, and again, slightly change. So how to distribute this pile, this whole pile? And the first thing that comes in mind when we talk about a big staking protocol, as big as LIDA, for example, or as big as any other protocol on the market, is reward smoothing. We all heard a lot about MEV smoothing pools, about smoothing rewards in general, because the system itself is not made to be beneficial for small stakers, for the people running couple validators. It is made to be apparently, it turned out that it is made for big operators. So why not to let small stakers benefit from being a part of a big protocol? But there's an issue. And the issue is, if we build a permissionless system, we cannot just say that, okay, we have 100,000 participants, and we will evenly split rewards between them. That would not be true. That would never work, because you never know how people would perform since the entry is permissionless. So it would be beneficial only for people actually performing bad, because they will get more rewards than they would get when performing on their own, right? But reward smoothing is still a cool feature. Now let's try to figure out how we can combine these two facts. Imagine we have 5 validators, each of them performing individually. As a performance metrics, we would use the simplest possible thing, attestation rate, ratio between successful attestations and total number of attestations assigned to this validator. Then we will draw a line. We will call it threshold. And what it would mean that any validator with the performance above the threshold is now called good performer. And any validator below the threshold is called bad performer. But what it has to do with rewards. And that's the most interesting part. So if you are a good performer, you will get these socialized rewards. But if you are a bad performer, you will get no rewards at all on a delegated part of a stake. And even though validators below the threshold would still get some rewards for the common pool, they would not get any share of it just because of the fact that they are below the threshold. And these rewards will be distributed between well performers, making this system a very, very good incentive for people not to be bad performers, but to be good performers, and to get this smooth piece of pie, I would say. So that brings us to the overall concept of the CSM Performance Oracle. First of all, it uses attestations as the main performance metrics. And it utilizes the performance threshold concept to distinguish bad performers and good performers, to calculate the rewards distribution. But as you might have noticed, we are talking about individual validators. And these calculations are impossible to be done on chain. It will be enormous in terms of gas. So that's why a Merkle tree is used to submit this rewards distribution on chain, and only a root of a Merkle tree is submitted, and then the rewards might be claimed. Okay, now let's move back to the initial permissionless trilemma. It turns out that we have just addressed all 3 aspects of this concept by introducing you a new product called CSM. And for me, CSM is the best fit for this trilemma. But if you want to learn more technical details, again, as I've mentioned last time, if this talk was not boring enough and you want to get into even more boring stuff, then go check it out, the discussion about CSM on Lido Research Forum. That was basically it. I'm always available on Telegram for any questions, suggestions. And the final thing, CSM is still under development, but we are about to launch testnet probably within less than a month. And the one last thing. Some say that if someone of you guys sitting in the audience or probably watching the stream is really interested in joining CSM with a small but very pleasant benefit, some say that you need to scan this QR code and get yourself an OAT. It is some analog of POAP for some reason called OAT, no matter. Anyway, go scan it if you want to join both CSM testnet and a mainnet with a little benefit. And that's it from my side. Thank you.
Thank you, Dimitri. We have time for some questions. Yeah, please.
Yeah, thanks for the great presentation. Was very interesting. Just a question regarding the attractiveness. You, as I understand correctly, you basically classify between 2 groups, right? The operators not good enough, kind of not going beyond this threshold, and the ones kind of performing better than this threshold. Is there any incentive in kind of performing even better? Like I imagine there's a group then, kind of operators performing maybe good enough, and some maybe have a setup like put a lot of effort in performing really well. Is there any incentive or is there the idea of an incentive to also reward those who are even better than the average good performers?
Thank you for your question. That's a really good question. And the simple answer is no. There is no incentive to perform either at the very bottom, like a bit above the threshold, or at the very top. But the thing is that it is extremely hard to actually maintain your performance not at the very top level, but on some level like 97% precisely. It's really hard. So the reality is that especially solo stakers, they all try to perform as well as possible. They try to maintain their setup. And if they face some issues, some small issues, they should not be penalized for it. However, if they perform really bad, if a participant performs really bad, he should be penalized. But we understand as people who design this module that incentivizing the very top performance might be a good thing. But for CSM, we propose another idea. We propose the idea that you need to be okay, and if you can perform better, you can perform better. It will be beneficial for the common pool, and all of you guys will get more rewards. And we believe that it is extremely hard to keep like at the very bottom, like just technically. So no, there's no incentive to be at the very top. There's an incentive to be at the top batch, but not at the very top.
Any other questions?
Hey there. So you mentioned something that the validators or the operators that can tip the scale, that have enough power, enough ETH to tip the scale to turn the penalty system into the red.
Yes.
Those are not the target of CSM. Therefore, they just won't opt into this system. That makes me think, is it like if they are not incentivized to join CSM, is it because the permission set is more, gives more rewards to the operators than the CSM?
That's a great question. Thank you, Paul. It is really hard to compare CSM with the permission set. Why? Because to join permission set, on one hand, you don't need to put any bond, I mean in terms of, in a form of ETH, but you need to put your reputation at stake, and you need to pass all this process. At the same time, with CSM, you don't need to ask permission, you can simply add funds. So there's two separate ways, and I would say that if you, as a node operator, is actually capable of running that much validators, at the current state of the network, it is something around 12,000 or more validators, then you would probably apply to be a professional operator, or you would maintain the business on your own. You don't need this staking protocol. So for CSM, we are not saying that you are not allowed to enter if you're a big operator. We are saying that huge operators would most likely follow the other path, or their participation within CSM would not be that significant. Thank you, Paul. Do we have time for one last question?
One last question.
Yeah.
How do you see the CSM meaningfully contributing to Lido's decentralization, since only 0.5% will be allocated to it?
Wow, where did you get this number of 0.5%? Probably you are thinking of simple DVT at the moment. Let me clear the picture for you. So from the very start, it is assumed, again, it is to be decided by the Lido DAO. I'm not the person to decide, but it is assumed that CSM will start with 1%. However, again, as you can see from the initial proposal, this cap would be gradually raised, or will be proposed to raised up to 10%, even with the very first version of the code and the security assumptions. But I can assure you that even though CSM version 1 is not released yet, we are already working on CSM version 1.5 or version 2. So this is just the very first step. And I mean, if you are standing on top of the mountain and you want to get to the bottom of the mountain, or vice versa, you cannot do it with one step. You do it with gradual steps. So what you see now is the very first step in a multiple steps. So multiple steps would follow. And I do believe that, again, this is my personal opinion, I do believe that the end game for Lido core protocol might look like multiple versions of CSM with different parameters, so that even curated operators might probably be offered an opportunity to join, like not the curated operators, but pro operators, larger operators might also be offered with the opportunity to join, for example, CSM-like module with a bond. So I would say that in terms of decentralization, this is a very important step, still a very small step, but a very first step in a row of multiple steps.
Thank you for the participation.
Thank you.
Next up, Raul Calvo from Nectar Network, and he's going to be talk resilience through the implementation of DVT. Please warm welcome to Raul.
Thank you very much. Well, yes, first of all, I think we are missing one part with the title, because we are saying resilience through implementation of DVT, and actually, as I'm representing Nectar Network, is resilience through implementation of DVT, not just in staking, but also in re-staking. It's funny that I am speaking after Lido, I mean, for two things. First, I'm not the most technical guy in the room, so Alex knows way better than myself all the technical details. And the second fun thing, or fun fact, is that one of the key drivers that made us build all of this, it was actually to avoid centralization within Ethereum. There are certain ways to prevent centralization, and the way that we decided to fight against centralization was through a technical innovation. That technical innovation is DVT, and is what I'm explaining here. It's the core of everything that we are building, and we are developing our own DVT technology. And why is that important? With a centralized Ethereum network, actually, it's not even a network at all. It's just a bunch of players controlling a distributed ledger, and they can be able to modify whatever they want. But the biggest issue that we are facing right now, because I think everybody has spoken about why centralization is bad for Ethereum, I think one of the biggest risks that we are facing, and is what we are trying to fight against from Nectar Network, is decentralization within re-staking. Everybody was actually fighting against Lido, decentralization powers. We were asking about how Lido is decentralizing, is based off operators and validators, but nobody was taking care about one major and obvious centralization force, which is eigenlayer. What is re-staking? To understand what is the danger of one single agent controlling the whole re-staking market, we have to understand a little bit about how re-staking works. Re-staking at the end of the day is no more than using Ethereum's collateral to secure other things. So the concept is relatively easy. And what, in my mind, is not well explained most of the times, is that you are not slashing a validator in Ethereum. You can force a validator in Ethereum. You will be able to force a validator in Ethereum to exit. once AP 702 gets implemented, and with our solution way sooner than that. But the slashing doesn't happen natively in Ethereum. That is not going to happen. So first, you are forcing a validator to exit in Ethereum, and you are penalizing that validator. You are slashing that validator in the AVS, in wherever that validation is rendering the services. Is that bad? Is that inherently bad? Not really. One of the things, so the good things that the restaking brings to the table, and it's something that we have discovered, again, we migrated from LST or pure LST to restaking. One of the things that we discovered when analyzing restaking is that economically, it makes the total sense. If I want to bootstrap a network, why should I start from zero and get something brand new, try to bring along operators, get my whole economic system when I have all the people that is working already in Ethereum and they are doing an excellent job? Let's try to use that. I mean, let's try to make Ethereum the center of this beautiful universe that we are building in here. And one of the best things that you can do actually by doing this is that you know that all those node operators that you are bringing to your system is people who is actually performing a good job in Ethereum. You get that trust of that people that is engaged in something way bigger than whatever you're building. And the last point that is extremely important is the revenue, the pure economic system. One of the things that everybody's complaining about is, okay, being a sole operator in Ethereum doesn't give me that much benefit. At the end of the day, the APR nowadays will be on the range of 4% or something like that. But if we have another sources of income to all those people that are helping to secure the network, you are making an economic system sustainable. Yep. One of the good things that we get also in the restaking ecosystem, or when you are implementing restaking, is that you can do everything way more modular. You can craft anything at your demand. Because you are creating something new, at the end of the day, again, when everybody is asking, what is restaking at the end? Okay, it's just using Ethereum security to secure something else. That is the simplest answer of all, even for me that I'm not technical at all. But one of the things that we have to take into consideration is that there are dangers out there. And the biggest danger, and is what Vitalik was saying in the phrase that I was mentioning before, or that I was showing before, is that you cannot take all the social consensus from Ethereum and endanger the Ethereum network to your private use. One of the things that we are seeing, I'm just mentioning it because it's obviously the obvious case and the leader in the market. One of the issues that we are having with EigenLayer, even now that they have launched the Eigen token, is that I think for everybody that has been here for a while, it brings a lot of vibes like FTX, all the Luna thing. They are going to use Eigen as a way to secure AVSs. So, okay, you are using your own token to secure a network, and you are trying to mix up Ethereum and all of this, and you are implementing a fork of your own token that is going to be decided by the community. How does it going to be? I mean, how does it going to affect the Ethereum layer? How does it work? How does it fit in? In general, we are avoiding that principle of, okay, let's use our own token as collateral, because truth to be told, we have previous experience with that, and it didn't work that well. So, coming back to DVT, what DVT does and how it's being used here. Again, I mean, doing this talk after CSM is kind of weird. I mean, I'm not going to explain once again about DVT because he most probably has explained already what are distributed validation technology. But just to simplify, at the end of the day, what you want when you are implementing a new network is that network needs to be live. I mean, you need liveness. That is obviously clear. But the most relevant thing of all is security. You need that security in order to avoid the slashing. So you need something resilient. And that is what DVT brings to the table. How does it work? again, it's relatively easy to understand. At the end of the day, what you have is you are getting something that needs to be signed, and you are splitting that between different nodes, and they have to sign, you have to recompose that key share, so everything gets signed. To understand how it works, I mean, and also the security and how this affects the security of the network, even in CSM, in Lido, in every application, OVL, SSB, you have two variables. One is, okay, you have to make subsets, and you can use any number that you want to use between the nodes, 5, 7, 16, 22 if you want to. The only thing that is going to top you is the latency. And you have to decide what is the number of those nodes that need to be what performance, using the analogy that Alex was using before, and how many of them can fail. What is the thing? There is something that sells a lot, which is, okay, I'm going to make sets with a ton of nodes because I'm reducing the collateral that needs to be deposited by each single node. That is kind of the most commercial approach, but generally, from a technical point of view, is not the best approach. And again, you have to find an equilibrium of the security over what is commercially attractive or the way that you democratize. So you have to find always a way in the middle to handle all that diversity in both performance of operators, geographical distance, and position. What are the benefits? I mentioned some of them, and also Alex was mentioning some of them. What we are trying to do here is, I always like to say, create a layer 2 of validation over the Ethereum itself. So we are lowering the collateral per operator, so we are making everything more accessible to everyone to become an operator. We always say that our dream is that anybody without knowledge of technical knowledge or without coding experience will be able just following clicks to become an operator or a validator in Ethereum through our DVT network or our DVT solution. That is on the validation side. On the risk-taking side, obviously, is that but increasing the source of revenue and the services that a node operator can provide. By doing that, we are increasing the decentralization of the network because we are enabling more participants. We truly believe that Ethereum should be open for everyone and not just to professional node operators. This has been kind of our motto, and we said that it doesn't really matter if you are a really bad performer. I mean, obviously, the network will kick you out if you are a really bad performer, but it has to be resilient, and we have to give that chance for everyone who is not really an excellent performer or is not a professional operator to participate in securing the Ethereum network. Because if we want to decentralize the network and to democratize the Ethereum network, we have to give it access to everyone. The biggest issue that we are facing, and it's something that has been mentioned in the previous talk as well, is how do you estimate the penalties that are going to be imposed on each one of the participants in the network. When you are distributing all the nodes, one of the issues that you have is that you have multiple actors, you have to track performance, you have to assign individual penalties, and that is extremely, extremely complex. And just kind of to sum up, because at the end of the day, that was kind of the main goal of the talk is, okay, we have explained what is DVT, we have explained how it's being implemented on validating in Ethereum, but how does it match with reestaking and what does it bring to the table when talking about reestaking? And the truth is that when we are matching DVT with reestaking, we are creating a way more secure environment there where it's needed the most. Because at the end of the day, one of the biggest risks, and coming back to one of the first slides, one of the biggest risks with restaking is that you are using Ethereum security for other things, So you truly need to secure or to give a more resilient way to do that. Otherwise, you are going to create a cascade effect that is going to affect us, all of us, everybody who is building on Ethereum. I think I've done the presentation way too fast, so I'm going to have a lot of time for questions. But actually, it's pretty much up to here. Thank you very much, everyone. If you want to reach out to me, just do that. I'm in Telegram, Discord, whatever you want. Thank you very much.
Thank you, Raul. Any questions? Yeah, please.
Thank you for the talk. Maybe like a simple question, I'm not that deeply familiar, but in DVT, when we share the key, is the key recombined at some point at some node, or are nodes exchanging signatures that they like sign gradually?
One node is not the owner of the key itself, is what you mean. I mean, at the end of the day, it's recombined, but it's recombined by the whole set. They have signed and it's recombined, but at the protocol level. It's not that it's owned by one node and it's pushing. It's like there is a cluster.
I'm just curious, like, how is this data exchange coordinated? Because if we're like 3 nodes, that one node must sign first and then transfer this half-signed transaction, if you will, to another node. So who does this coordination? How do they send this to each other?
Actually, there are different implementations depending on the protocol. I think OVAL and SSB, they have their own way to do that. I think, maybe I'm mistaken, but I think OVAL, they do appoint one leader within the subset. In our case, it's a random system. We have designed our own sort of consensus mechanism, which actually appoints randomly one node within the subsets.
Any other questions? Thank you for the participating. Thank you. Next up is Nixo from EatStaker.
We are early.
Oh, sorry?
We are early, so 5 minutes pause.
Okay. Okay, next up is Nixo from EatStaker, and she will be discuss about, does Ethereum really even need solo stakers? Please, warm welcome to.
In the next 5 minutes.
Oh, sorry. Okay, we will wait 5 minutes, 4 minutes, and then we will continue.
Always start like trying to start punctual.
Okay, after this talk, I will also show something, but it will really small, really short, almost 1 hour, 2 minutes.
Okay.
So
then you say like we do a little pause from 20 minutes, and then that's it. And after 20 minutes, you will introduce the next speaker again. All good. No problem. Easy.
Sorry about that, guys.
This is die Bank.
Anton, wer steht der Letzte? Da habe ich keine Präsentation. Das ist, oder ist die jetzt später reingekommen? Weil sonst waren alle heute früh da. Ah, da ist eine jetzt. Von wann ist die von heute um?
We are ready? Okay, okay, thank you. Okay, we are ready to continue. Next up is Nixo from ETHStaker, and she will be discuss about does Ethereum really even need solo stakers? Please one welcome to Nixo.
Okay, first of all, thank you guys so much for staying so late and listening to me talk. Put that right there. So first of all, this is going to be a rug. This presentation isn't really about solo stakers. It's about whether or not Ethereum is really sticking to its values. So let me introduce myself first. I'm Nixo. I'm the executive director of ETHStaker. We are a nonprofit. We don't have a protocol. We have nothing to shill. And we are first and foremost a community of stakers. That is how I got involved in ETHStaker. We are committed to the health and decentralization of the validator set, and that means creating new solo stakers and supporting existing ones however we can with resources, tooling, community events, and advocacy. So we're going to go through some definitions first because in the beginning there were solo stakers and there were professional operators, and it's gotten a lot more muddy since then. So we have solo stakers, home stakers, remote stakers, managed stakers, professional stakers, liquid stakers. So these first five, solo, home, remote, managed, and professional, these are operators who run validators whose indices they know. But of those first five, these first four are ones who are using their own capital in those validators whose indices they know. But I do want to point out that last category, managed stakers, don't actually control their config, and so that means they're not choosing the clients that they run, and they're not directly choosing whether or not they use MEV-Boost or if they build blocks locally. So these first three categories are what I would call independent operators, and that's primarily who we'll be talking about here. So solo stakers, home stakers, and remote stakers. Remote stakers can be anybody who uses the cloud or uses some bare metal service but still controls the configuration of their validator. So we will go through some characteristics of independent operators, and I do want to preface this with I'm going to be focusing on the criticisms that we hear of solo stakers to genuinely address these criticisms. Solo stakers are usually difficult to organize. They don't all come to ETHStaker. They don't all have the same community. Some of them just set up their validator, let it run, turn on notifications, and don't pay attention otherwise. Some of them are super engaged. They're inconsistently compliant with local tax laws and local laws and tax regulations. They have no investors. They have no customers. They have no one to answer to. We have no idea if they're adhering to their local jurisdictions. They have no redundancy. So when their validator goes offline, they're offline. Nothing else flips on. And that's usually. Some stakers do, but most stakers do not. They often or sometimes have bad performance. And to illustrate this, this is a graph from Tony's timing.pix. And Kiln is one of the biggest professional operators, and you can see that they usually, so this is a graph from January to April of this year, and you can see that they miss less than 1% of slots. They're very good operators. In contrast, solo stakers and rocket pool node operators, and I'm using rocket pool node operators because they make up a large percentage of independent operators. They miss like 5% of slots, which is significantly different. They're poorer operators than professional operators. They react unpredictably to economic incentives. They've been referred to as irrational actors, which means that there's not necessarily a one-to-one correlation or any sort of correlation. When APR goes down, they don't necessarily exit because of the APR, and if APR went up, which really doesn't happen, there's not necessarily a correlation of solo stakers or independent operators on the network. They occasionally have poor key management. We see people come into ETHStaker saying, I lost my key, I don't know how to read my seed, or a lot of other things. They don't have investors, they don't have customers, and so some of them are just sort of YOLOing this. They don't have exit plans or death contingency plans. We have seen that there are Genesis validators who have been active since the beacon chain launched, and they've been offline for months or years. And I suspect that some of those people have died, which is morbid, but when you work for a team, when you're a professional operator, you have a whole team. So if something happens to one of you, it's not that big of a deal. But with somebody who's solo staking or doing this and their husband or wife doesn't know how to recover those funds, it means that those funds are just going to stay in the beacon chain for like 10 years till they get exited, and then they're just going to sit in a wallet. And they need a lot of help troubleshooting. This is why eStaker exists. If you go into the eStaker Discord or the eStaker subreddit, you see that it's a really active community of people who need help all the time, who are helping each other. We've got networking experts helping people who are really good at Linux but don't know anything about networking. So the natural question after this is, why the hell would we want these people running the consensus layer? Why would we want these people responsible for the security of Ethereum? And to answer that, we have to talk about the fundamental value of Ethereum. And I'm curious if anyone here is willing to throw out like one sentence about what they think the fundamental value of Ethereum is. Love it. Love it. Okay, so let's start off from the basics. There are no unilateral decisions. To make any decisions, any proposed changes in Ethereum, you have to go through this public governance process. You have to do a bunch of research. You have to have a bunch of discussion. You have to propose an EIP. You have to go through the all-core devs call. You have to make sure that it's going to be compatible with everything else that's going into Ethereum, that's everything else that exists on Ethereum. And for this reason, it doesn't tend to favor any one company over any other company, because the devs wouldn't do a whole lot of work to favor one company over another when it doesn't benefit most of Ethereum. And there's this aspect of trustlessness and immutability. When you deploy a contract, when you make a transaction, once it's finalized, you can be pretty sure that nothing's going to mess with it, nobody's going to censor it. So I looked online to see what other people were saying, and I heard global settlement layer, internet of value, something software-based, easy to audit, non-reliant on human judgment, and credible neutrality. But the one I liked best was from Paul Brody, who's the head of blockchain at EY, which is one of the big 4 accounting firms. And he says, the entire value proposition of blockchain technology is built upon decentralization. For the more politically inclined, they see it as censorship resistance. For those of us in business, the value proposition is about monopoly resistance. We live in a world of extractive technology monopolies that we don't need anymore. And I love that because it highlights Ethereum as a framework for actual competition. So why would we want network? Why would any network want independent operators? Because independent operators are an anti-fragility measure for Ethereum. They're key for censorship resistance. So if you have a couple big protocols running all of Ethereum's consensus layer, basically they can be cajoled, they can be pressured to do certain things on the network. But if you have just a few solo stakers, even just a few small percentage of solo stakers who can't be influenced, identified, organized, who aren't necessarily following their jurisdictions, like who live in a bunch of different jurisdictions, censorship that contributes to censorship resistance. You only need a few who can build blocks locally. They have an outsized impact on protecting the fundamental value of Ethereum. This is a snapshot from last November of consensus layer client diversity. I'm going to assume that you guys all know about client diversity and why client diversity is important, but you can see at this snapshot, most of the network used Prism. And Rocket Pool had switched so far away from Prism that only 5% of their operators were using Prism, and they had switched to mostly Lighthouse, Teku, and Nimbus. And they were responsible for, independent operators in general were responsible for a lot of the pressure that made larger professional operators switch away from these majority clients. and they're more ideological than profit-driven actors. So this is why I say that this presentation isn't actually about solo stakers. It's about constantly questioning whether Ethereum's fundamental value is still there. It's just how many independent operators we have is just an indicator of Ethereum's actual decentralization. Everything else is just talk. If we wanted the most efficient operators and the most efficient network, I would argue that we wouldn't use blockchain at all. So how do we keep independent operators on the network? eStaker, partnered with Obel, recently did a survey last month that asked a bunch of stakers their opinions on why they stake, how long they're going to stake, how they feel about staking, what kinds of hardware or software that they use. It was a lot. But one of the things we asked was, how have your views on the value of solo staking for Ethereum as a protocol changed since you first started staking? And pretty uniformly, people said that they think solo staking is as valuable for Ethereum as they did when they first started staking. But when I asked, how have your views on the value of solo staking for an individual changed since then, about a third said less favorable, meaning that they feel a little salty and that they do feel like they're not getting, that they're getting the short stick a little bit. And when I asked, when we asked how well represented they feel in protocol research, the answer was kind of a meh. It was in the middle. They didn't necessarily feel like they were getting most of the attention that they deserve. Despite this, when I asked how long people plan to run a validator, most said that they have no plans to exit, or they'll exit for an in-real-life goal. There was an equal number who said that they'll exit under a specific yield, and this is coming right after stuff like issuance debates and liquid staking protocols being more profitable than just running yourself, especially with hardware requirements. And so, so how do we keep the operators on the network? Despite this saltiness that they're feeling, we need to represent their actual needs in their own words and research. So that means getting a lot more feedback from them, encouraging them to speak up, encouraging them to come to conferences, and not letting liquid staking protocols speak for them in research in defense of solo stakers. The financial incentive needs to be from solo stakers, because if liquid staking protocols speak to defend solo stakers, I don't believe them. Economic competitiveness. Solo stakers are not, they may be ideological, but they're staking because they make money staking. They need to be economically competitive with all these other large protocols that are benefiting from the economy of scale, the economies of scale. And that means mitigating centralizing aspects of MEV and builder research, or builder dependence. That is more research. Lowering the financial barrier coupled with decreasing hardware costs. That's, again, more research, stuff like Verkle trees, EIP 4.4s, and research around single slot finality. And extra incentives. There's recently been a string of airdrops to solo stakers, and that is awesome. Especially because it has incentivized this organization called StakeCat to put a little bit more effort into creating a solo staker list, something that's better at identifying solo stakers, and eStaker is closely following that and hoping that future protocols that do airdrops to solo stakers use that list. There's also smoothing pools. There's Smooth and Smoothly, which anybody can donate to, and we definitely advocate for that as a way of incentivized solo staking. If any protocol wants to donate, all they have to do is send to the smoothing pool addresses. You can talk to Lansky about this afterwards. But again, sorry, these are not permanent solutions. We cannot rely on this to be the thing that incentivizes solo staking, because this is unpredictable, and it really needs to be a protocol level change that incentivizes solo staking, that changes the framework so that protocols that are benefiting from the economies of scales aren't the ones who are most profitable. We need to onboard new stakers with education, better UX, lower hardware requirements, and better software and protocols. That is all above the protocol layer. That's all really important. eStaker is doing its best to make sure that we support anybody who's working on that. So if you are working on something that is maybe open source, unincentivized, doesn't take a cut of solo stakers, if you're working on some tooling that helps but doesn't take a cut, please reach out to us. We would love to help you. And continued technical support. And again, that's where eStaker comes in. Vigilance for vectors of centralization. So that one is if a protocol comes and says, every solo staker should use us, we're a great protocol, we are some sort of layer that everybody can put on their validators, we need to be very wary of that because that does create some vulnerability in a vector of centralization. And we can't rely on their altruism. If we continue to say, oh, solo stakers will be fine because they're ideological and they're there because they want to support Ethereum, we will end up with no solo stakers. I encourage you to use this QR code or the link below it, which is the same thing, to read this blog post that Vitalik recently came out with, because he does talk about sort of this was in response to the Dankrad from the EF and Peter from Geth having a discussion about like MEV and builder centralization. And he really does a good job of talking about the current landscape, how we got there, the centralization issues, and how current research is taking us away from that direction. That's it. Thank you very much.
Thank you, Nixo. Is there any questions? Yeah, please. Oop. Which one? Yeah, please.
Thank you for the talk. You mentioned like one of the criticism of individual stakers, like one of them being that they don't have the contingency plans, and secondly, they are not always compliant with like local laws and taxes and stuff. Like my question is, why do we care? Isn't this just their individual problem? If they don't stake for some reason, then that be it.
Yes, absolutely. We don't care. We don't care at all. But the thing is, like a known entity in the US or some sort of country that cares a lot about what the US is doing, if they're a known entity and the US wants them to comply with something, they can influence them. And we can't really tailor Ethereum to adhere to one jurisdiction, because then we would have to tailor Ethereum to adhere to all jurisdictions, and that would be really insanely painful.
Hello. You've mentioned this list of solo stakers, and you even mentioned that it is somewhat better than the list prepared by Rated.
Yes.
Can you name specific aspects why you believe it is better?
Yes, because the rated.network list only goes up to 500,000, the index 500,000. So the only update that they have made is basically people came in and said, I'm not on this list, and they did one update, and they do not plan on continuing to. Elias told me that he does not plan on continuing to maintain this list. Whereas GLC has done a lot of work, and he's also made an effort to exclude managed stakers. So he has two lists, one that includes one that's a floor, one that's a ceiling, and one includes a lot more, has a lot more breadth of different types of stakers, and one has just a true list of independent operators. And he is taking a lot more feedback. And in general, when I go through all of the conversation from solo stakers in both the subreddit and the Discord, they check both lists, and most of them say that they're on StakeCat's list, but there have been a lot of issues with Rated.network, and people were very upset with the last couple of airdrops that happened because they were not on that list.
So I have two questions. Recently there was a research posted about negative yield on ETH. I wanted to know your take on this.
About what?
Negative yield on ETH.
So the issuance changes.
Yes, that is one. And other is, do you think risk-taking could be a good incentive to keep node operators engaged?
Okay, so issuance changes, I know that it's very contentious, but I'm actually very much supportive of issuance changes, only because our current issuance regime leads to liquid staking protocols gaining more and more traction. Every percent more that we have on the network is mostly liquid staking protocols, and part of that is because of restaking, the whole restaking thing. And so I do think that I don't believe negative yield is ever going to be a good issue or a good solution, because I do think that that will result in solo stakers being adversely affected in a way that liquid staking protocols can put up with for longer. But the current issuance debate is around this intermediate proposal that says let's just lower it and lower the incentive to stake while we figure out what the other things that will incentivize solo staking are. Like, I really like Vitalik's idea of correlated offline penalties, because that better identifies validators who are just doing it on their own, because if 1,000 validators go offline at once, you know that it's probably a larger staker, and I don't even think it's 1,000. I think the threshold is much higher than that. But I think that it's a very good idea to have this intermediate stake rate that is lowered, so that we don't have 80 or 90% stake by the time that we come up with this other issuance proposal, because then we'll have 80 to 90% arguing with the fact that they want to keep this structure that they're highly benefiting from. Oh, and restaking, I don't know a lot about restaking. All I do know is that I know it's not live in its full capacity yet, but I do know that I have seen a huge influx to liquid staking because of that, and actions speak louder than words, and they say that they're supposed to that there's supposed to be some benefit to solo stakers, but solo stakers can't be AVSs, so I don't really know how much it's going to help solo stakers, especially in light of the fact that APR is going down because they're incentivizing liquid staking so hard on Eigenlayer. Well, you know what I mean. Yeah.
Thank you, Nixo. Is there any question? No. Okay, thank you. Thank you for the participation. I need a cable for the. Oh yeah, thank you. Oh yeah, sorry. Yes. Can you hear me? Oh yeah. Thank you for the participation at the DappCon. As you know, maybe you know, we are organizing a new campaign with the DappNode, and we want to extend the campaign in here. So when you claim the POAP and go to the raffle, you can win a Gnosis Chain specific, Gnosis Chain branded DappCon with a 4GNO. So yeah, please mint and join the raffle. We will announce the raffle result tomorrow at 4 p.m. Yes, please join and claim the DappNode POAP. Yeah. I think we are ready to announce next speaker. He's not here. He's here. Okay, we have 5 minutes. After 5 minutes, I will announce the next speaker. So yeah, enjoy the climbing part. Ready? Okay. We are going to the final presentation. And Anton from EF, he will talk about, I like big block, and I cannot lie, me too. Exploring, scaling, call data pricing, gas limit, and blob counts. Please, warm welcome to Anton, please.
Perfect. Yeah, hi everyone. I'm super happy to be here to talk about a topic I'm actually very passionate about, which is big blocks. But to be honest, I was a much bigger fan of bigger blocks back in the days when Bitcoin had the discussions on big blocks. So I was in the big block camp, not in the crack right camp, but I was for the big blocks. And over the years, getting more and more into the depths of the protocol, I would say I turned into a small blocker by now. Still, the title of my talk is I like big blocks and I cannot lie. I will come to that later. You will see why big blocks. But yeah, don't waste any time and get into it. So on the side, you can see the agenda I want to talk about. I'm basically starting with the components, with the variables that make a block big, which is the block size, starting with the block size, and then we have the gas limit, call data, and the blobs. And then I want to quickly go through a practical example, why big blocks might be an issue. And finally, I want to outline two proposals that are currently, one of them is considered for the next hard fork, for Pectra. The other one is, a little more in the future, was just proposed a few weeks ago. And I want to quickly highlight them here. But from the beginning. So if you look at Etherscan, this is kind of a quite present screenshot I took from Etherscan. We can see that the block size has steadily increased, and especially at the end of 2023, we saw this big spike in block size, which was mainly caused by rollups and not blob inscriptions, but inscriptions. So people just posting some arbitrary data. Doesn't matter if it's a rollup or some user, but people posted arbitrary data to Ethereum L1, and they used call data for that. Now, with shipping the Dencun hard fork, the block size calmed down. We are currently at a level of 100 kilobytes per block, which is, I would say, quite healthy. But you can already see we were at almost 200K bytes, as you can see here in the chart. Before getting deeper into it, let's quickly summarize what actually contributes to a big block. And first, we have, of course, the gas limit. The more call data you can fit into a block, so you need a lot of, for example, if you increase the gas limit, you can fit more call data into your block, which then also increases the block size. Second, the call data cost itself. The cheaper the call data, the more call data you can put within your gas limit, which also contributes to a bigger block. And finally, since 4844, we have blobs, and blobs also contribute to bigger blocks. I assume here now that blobs are part of the block, which is technically not true, but still, if you look at it from a networking perspective, I just count the blobs here into the block size. But yeah, forgive me for that inaccuracy. This is kind of the same, but in a little bit more visual representation. You can see before we did 4844, the two main contributors to big blocks were basically the gas limit and cheap call data. So both of them on 2 axes. And then we have 4844, which kind of added 6 blocks on maximum to the current block size. And finally, on the right-hand side, this is what I will talk about a little later in my talk, which is basically an idea of shrinking down the EL side in order to make room for more blobs. But this is then part of the proposals section. Let's first look at the history of the gas limit. You can see this chart shows you the gas used per day, so kind of the summed up gas per day from the beginning since Ethereum launched until quite recently. And the important part in this chart is this section. So this is kind of everything that happened after the London hard fork. So the London hard fork introduced EAP 1559, which kind of created this very nice level, very stable level of daily gas limit used. And if you look closely, you can see that at some point it got very stable. And this is when the merge happened, because with the merge we got a constant slot time of 12 seconds, which meant that the block, the gas used per day stabilized basically at the target, which is super nice to see because it basically also shows us how nice ERP 1559 worked together with the merge and with a constant slot time. Right, this is basically everything I already said. The last point is maybe a little also important. I want to outline that that the gas limit is not controlled by anyone except the users or the node runner, the people running nodes. So the gas limit is raised by the nodes together. So basically, every time we raise the gas limit, it's not like we do a hard fork and just raise it. It's basically the users deciding we raise the gas limit together. And there's currently a community effort. You can find it at pumpthegas.org, where you can basically opt in to signal that you want to increase the gas limit. I'm not for increasing the gas limit, but yeah, I think it's super cool to see the community coming together and coordinating such a change. The gas limit also affects the maximum possible block size of today. What you can see in this chart is on the y-axis, the size of a compressed beacon block. So compressed with snappy compression, which is kind of the standard nowadays in Ethereum. On the x-axis, you can see different gas limits. And what we can see here is today, by just simply calculating the compressed size by using the gas limit divided by the non-zero bytes, the cost of the non-zero bytes gives you the current maximum possible block size. This is still simplified, we'll come to that later, but when we talk about block size, so this is very important here, when we talk about block size, there are different block sizes. First, we can talk about the compressed block size, which is maxed by taking the gas limit divided by the non-zero bytes. Non-zero bytes because snappy compression is very bad at compressing random non-zero bytes. Without snappy compression, the maximum block size is actually above 7 megabytes because you can just take the gas limit divided by the gas cost for 0 bytes, which is 4 at the moment. So if you do 30 million divided by 4, you arrive at the block size of over 7 megabytes, which can be compressed, I think, to around 0.5 megabytes, even lower. So this is not a big problem because snappy compression is very good at compressing a sequence of zeros. And finally, a third size within the protocol is within the engine API, which uses JSON format, and there you basically have to 2x the block size that you already have just because of some inefficiency of JSON. So talking about the block size, we always have to be very clear which block size we're actually talking about. Is it the snappy compression block size? Is it the block size without snappy compression? Or is it the block size within the engine API that then again doubles? Next, we have call data. Call data is currently also, I would say, a widely discussed topic, especially there is a EAP for increasing the call data cost. And currently, the call data cost per non-zero byte is at 16. And you can see on this chart here, if we would go lower, for example, if we would go from 16 gas per non-zero call data byte to, for example, 8, then we would essentially double the block size. And on the other side, the same applies. When we look at the evolution of call data, we can see that it was steadily increasing, but then with more and more rollups posting their data down to L1 using call data, we see this massive spike here, which was also in part, there were also some inscriptions, I think, that also caused this massive spike that you can see here in the chart. And what it shows us, there was a big demand for posting data to L1. Now, with having blobs, this demand calmed down a bit. We saw still some inscription spamming, but not at the levels that were present, as you can see here in the chart. Finally, the last variable that contributes to the block size are blobs. And what you can see on this chart is the beacon block in yellow, which is, as said, at around 100 kilobyte. This is the current average block size. And with 4844, we added a maximum of 6 blobs and a target of 3 blobs. So on average, we will see a picture like this, where you have an average size block of 100 kilobytes, and then you have to add 3 times 128 kilobytes in addition. So what this tells us is, with 4844, we essentially 4x'd the block size, because it was around 128 kilobytes, and now it's at 500 kilobytes. So even though of course, it's on the roadmap and it's great for scaling, but we should not forget that this came with the quote-unquote cost of increasing the whole test. It works. Yeah, as said, the target is at 3. The maximum number of blobs per block is at 6, and then you have already 6 times 128, which means you would have 7x'd the average block size that we had before 4844. And if you visualize that, it looks like this. We saw before we did 4844, it was we only had a block containing the CL part and the EL part, and with 4844 there were these additional blobs. And you can already see at the end of this chart, which still captures this blob inscription spamming we had, you can already see that it's basically the blobs that are responsible for the main load there, or for the main contributors to big blocks nowadays. The thing about blobs is it's actually quite nice because they're of static size. So if we add a new block, we know it's exactly 128 kilobytes. This is not the case for the EL and the CL part of the block. While the CL part is actually quite small, the EL part has a high variance. And you can see that here. This is an average block that you see on the mainnet today, where the CL part is only 20% of the total, and the EL part is around 80%. The problem is, if you look at the max blocks, so the biggest blocks that we see today, then this looks like this. This means 99% of the big blocks is caused by the very big EL part, and the CL part is basically 1% of the whole block. This means there is much room in the EL part and not that much room in the CL part. So this is the question, right? Are blocks too big? And I would like to please raise your hands. Who thinks blocks are already too big? No one? Yeah? Yeah? So can I then assume that everyone else thinks like, okay, blobs are not big and we still have some room? Yeah? Okay, let's look into this chart. So this is basically just comparing reorg blocks with non-reorg blocks. And what you can see here, although we can see that the size, the compressed size, so I'm now already talking about snappy compressed blocks, is higher for reorg blocks than for not reorg blocks, which might point to big blocks having a higher probability of being reorged out. We can already see that at the builders, certain builders, they limit transactions, so you can try to send a transaction that is over 100 kilobytes, send it to all those famous builders. You might have hard times getting that transaction in because the builder is of course concerned that your transaction that is so big might cause a slower propagation, which could mean the builder might lose all its arbitrage opportunities, all its sandwiches that he had in that block just by including your big transaction. So if you want to get such a big transaction on chain, then you better pay the builder well, because otherwise the builder will just discriminate and censor you. The thing is, there's still so much room until we actually reach the max block size. And this is visualized in this chart here. We can see at the very bottom, this is where we are today, the average block, which contains this small line of EL and CL part. We can almost not, and also the blob part is very small, but we could max it out until 3.5 megabyte. And 3.5 is the current maximum block size within, including blobs. So we cannot go higher. But this is, you can see this big gap between the average and the max, and you can already tell, right, this doesn't look very efficient. There is also this line about ERP 7623, but we can ignore that now. I will come to that later. Next, I want to show you this conversation I had with Perry from the DevOps team to come to my practical example that I wanted to present. You don't have to read everything, but it's basically standard, just a very standard conversation between me and Perry. So I'm reaching out to Perry. Hey, Perry, I want to build a big block. Can you help me? He's like, yeah, let's do it. I send him over the block, and you can see on the lower right side, I just put a signed transaction into a text file and sent it over to Perry. And you can already see the text file got quite big, right? So this is how it started, and what I tried to do was basically experimenting, right? I was like, okay, why not experimenting on Sepolia? It's a test network. What can go wrong? Yeah, something went wrong. And what happened, this is 1 month later. So basically at the same day, we submitted that block. We tried to use a Geth node. So we tried to submit my transaction, and Perry was like, yeah, something strange happened. We couldn't submit your transaction. Then we reached out to Justin from Beso, and Justin was like, receiving this file, and he responded something like, okay, nice transaction.txt, that's not suspicious, I will submit it. So Justin got it into a block, and my transaction was basically propagating through the whole network. At some point, I think it was then in the evening already, there was some Twitter user that was like, okay, I'm running a Sepolia node and I get some strange errors there. The DevOps team also looked into that, and basically there was a huge chaos on the Sepolia network. And what happened is summarized in this graph that Marius from the Geth team created. What happened is my transaction got included into a block of the Beso client. The block was then proposed. It was a valid block. It was within the 30 million gas. It didn't do anything wrong. But within the Geth engine API, there was a hard-coded limit of a block size. And this limit declined my block. Declined that block and reorged it out again. The problem was my transaction was paying very well. So all clients except Geth continuously tried to include my transaction, and Geth reorged it out again. And this caused some chaos on Sepolia, and it would have also been possible on mainnet. And this was kind of the very scary thing, because it's basically a very low-cost attack on the network that would mean that every time a minority client proposes a block, it would immediately be reorged out by the majority, by Geth nodes, which would mean the small clients would be punished by a bug that, that sits inside the majority client Geth. Right, and what I actually tried to experiment with was snappy compression. So I looked into how snappy compression works, and basically, until that point, I think most of the people assumed that the max size block is calculated by simply taking the gas limit and dividing it by the call data cost of non-zero bytes. Again, non-zero bytes just because they can be compressed not that well, and 0 bytes are much better to compress. The thing is, it actually looks like this. If you want to build a max size block, then you should reserve 71% of the gas for non-zero bytes, and then add 29% of the gas for 0 bytes. And this then gives you kind of this line where you can see that at exactly 29% 0 bytes, you can max out the bytes you can include into a block, while still making sure that snappy compression fails to compress. And this is just because of some very suboptimal compression that snappy compression does. And finally, let me quickly talk about some proposals that want to limit the max possible block size of today in order to make some room for increasing either the gas limit or adding more blobs to the network. First, ERP 7623, it's currently considered for inclusion for Pactra. ERP 7623, called increased call data cost, introduces this floor price for call data. It looks like this. And it basically, very simplified, it does the following. 99% of the transactions use the EVM nowadays, right? So all the pure data availability transactions, they moved towards using blobs. And only 1% of the transactions are still call data transaction, quote unquote. So they would be not affected, 99% of the transactions. All those transactions that still use the EVM would kind of be in the upper part of, or in the first side of this max condition formula. And only 1% of the transactions that are still relying on Ethereum layer 1 for data availability would be in the second part, in the lower part in this chart, and it would that mean that they would pay not 416, so 4 gas and 16 gas for their call data, but they would then pay they would then be 10 and 40. So we would just increase the call data cost for those transactions that rely on data availability and cannot move to blobs. Yeah, as said, it would reduce the maximum possible block size, which is super nice. So we diffuse this DOS vector. 99% of the transactions are unaffected, and it's basically only the data availability users that are impacted by this. And they can move towards block for most of the times anyway. Finally, a very new EAP proposed by Vitalik a few days ago, 7706, which proposes to do multi-dimensional resource pricing, just as we do with blobs already. Vitalik proposed to move even further and do multi-dimensional gas pricing for call data. The goal is, again, prevent big blocks. The problem is, or it's not really a problem, but the challenge is here, it's a little more complex than just increasing the call data cost. So it requires a new transaction type, which means we need to make sure that it's backwards compatible. We already saw with 1559 how hard it is for wallets to implement new transaction types, which might be the same here. So this ERP is definitely, I would say, much closer to the endgame solution than 7623, but it just requires some additional analysis. Right. This is basically everything. I've just put some link here so you can see there's a lot of analysis on big blocks on ETH Research. If you Google for 7623, if you just look for 7623, which is the EAP number on ETH Research, maybe you add EAP 7623, I'm actually not sure, but then you should find all the analysis done so far on the topic. And yeah, that's basically it. Thank you.
Thank you, Anton. Any questions? Please, Lion.
Thanks for the talk. So if builders are excluding transactions because they are big, isn't that clear evidence that call data is mispriced? And if your answer is yes, then do you think that with 7623 they would be able to drop such rules?
That's a good question. I would definitely agree that call data is mispriced. I would say call data is too cheap. So last time the last EAP I'm actually not sure when it happened. It's definitely before, or probably 2 years, 3 years, 4 years ago, even maybe even more years ago, when call data was decreased to the prices we have today to 416. And builders are, yeah, if you would now increase the call data cost, of course, then we would create more incentives for builder to again include those transactions. I think the question is then more, how much would you have to pay then in priority fees? Because the builder is just afraid to lose all the arbitrage opportunities, which he cannot revert anymore. So for example, there are builders doing centralized exchange, decentralized exchange arbitrage. So for the builder, it would be very bad if the centralized exchange arbitrage transaction works and it goes through, but then suddenly his block is reorged where the other side of the arbitrage sits in. So builders would kind of never have a real incentive to include those big transactions, only if you really outpay their arbitrage profits, I think. what was the second part of the question? If 7623 can help there. I think 7623 makes it just less dangerous. So I would say 7623 just makes sure that we will not see those 3.5 megabyte blocks. I would say those really maximum size blocks, they have no real use case except for being used as a DOS attack. Just as an example, for example, Starknet, they are still posting data down to L1 using call data because they use that call data within the EVM, so they need to do star verification, and their transactions are around 90 kilobytes, a maximum of 100 kilobytes, and this might be also a reason because it might be also based on considerations of builders not including their even bigger transactions.
Any other questions?
You had this nice graph that compared the two block sizes with reorg probabilities, or the other way around. Do you know to which extent this is, or the reorg is caused by just propagation because, or longer propagation because longer bigger size, compared to like execution, that the execution takes longer?
Yeah, this is a super good question. No, I don't know. Maybe bigger blocks just contain more computation, right? That would be the argument. And then if it contains more computation, it also takes longer. But I think there is definitely a relation between big blocks and a higher probability of getting reorged. And the thing is, those big blocks, they always have cascading effects. For example, if I'm a validator and I receive a very big block from the builder, I just sign the header, and then the block is propagated, then the block takes longer to be downloaded by all the other attesters and then attest to it. The next thing is, let's say my block is not reorged and my block makes it on-chain. Then the next proposer might have a harder time deciding, should I build on top of my block, or should I try to reorg that block out? Right? Because also this proposer saw that block later. This proposer also saw this block only received, let's say, 50% of the attestations and is not very strong. And then it's not only the validator that proposed the big block, but also the next proposer might have some troubles. And this is then this cascading effect that we can see in the network. If one block is reorged out, then the next block might also struggle in determining which is the right block to build on top of. But coming back to the question, I agree. So this chart doesn't make it very clear or doesn't reason very well about the fundamental, the very underlying problem there. It's just a comparison where one can quite nice see that those blocks that were eventually reorged out are also on average, I would say, quite significantly bigger.
So if a builder excludes a transaction that's big, why are they included blob transactions today if they are so cheap and so expensive in terms of size?
Yeah, that's a super good question. And it's actually, if you look at the builders of today, so I'm actually currently writing some analysis on that, and builders are already discriminating blobs. Not every builder. Some builders are just applying to the rules. But there is a builder, I will not call him out now, but one of the very big builders, you just have to look at the stats, is including less blocks than so the largest builder includes less blocks than the second largest builder, which shouldn't be the case on average. So builders are already pointing at each other like, oh, have you seen this builder does include so less blocks? Is he maybe playing with propagation time, with latency? And that, I think it's a big problem that is already happening today. Builders not including blobs because they don't make money from them, and it only increases their risk of their own nice juicy block being reorged out.
We need a .pix to the rescue.
Right, yeah.
thank you for the amazing presentation.
Thank
today.
you.
And, today our session has ended. Thank you for the whole participation. Hope you like it today at DappCon, and see you tomorrow.